Hey everybody, tonight we're debating whether or not gravity is a hoax, and we are starting right now with Ross's, aka Iron Horse's opening statement. Thanks for being with us, Iron Horse. The floor is all yours.
Thank you. The grave weight of the matter. Greetings. My name is Ross. My YouTube moniker is Iron Horse, where I've slowly been unraveling the truth about the world we live upon, exploring the nature of reality, and challenging mainstream narratives. I'm also found on Quora as Ross Iron Horse Thatcher, and I don't mind the odd debate on Facebook either. As a logician and a truther, I will have no need to share my screen to argue my logical points. If an argument cannot be explained in such a way that a 12-year-old could understand it, chances are you don't understand it yourself and prefer to hide your ignorance in secret codes that only the initiated understand, in order to bamboozle your opponent like the proverbial chess pigeon. I find the truth is best discerned by arguing with opponents rather than agreeing with those who already know it. I find exclusively it's those who specialise in a field who hold the strongest, most unswayable opinions. So today, I'd like to explore the origin of these opinions before proposing far more credible and likely explanations for literally the nature of reality. Gravity is the key component to today's beliefs in where we are, what we live upon. Without it, they say, we just float off into space. So let's explore why so many even believe in space in the first place. It's said that around 500 BC, it was first proposed that Earth was a sphere, conveniently in the centre of the universe, sitting on the shoulders of a giant, as the sun was carried across the sky on the back of Apollyon's chariot pulled by four mighty steeds. So the sun was basically God, the giver of light and life. Artemis was his wife, the moon, who governed the night. The planetae were the wandering stars, gods and goddesses, while the stars were angels seated in heaven. It wasn't until the mid-1500s that a certain Jesuit occultist proposed that, what if the Earth was another wandering star also going around the sun? Although laughing it off as preposterous and absurd, of course the Earth doesn't move. Copernicus was strongly encouraged to work on this thesis by the Pope, the basic idea being that under maritime law, anything found lost at sea belongs to he who finds it. So if the Vatican could discover the Earth lost in the galactic sea, they discovered the legal loophole to claim ownership of the entire world. The problem soon arose, however, as any young child first asked when first shown we live on a globe, what stops the people on the bottom from falling off? Even a child automatically sees how illogical such a concept is. This was solved around 1666 by Sir Isaac Newton, who discovered gravity on the assumption that when an apple fell on his head whilst writing alchemy formulas sitting under a tree, it might have stayed in motion until being arrested by the force of the density of his head. Or maybe instead he decided it fell because the bigotry of the earth created a force of attraction, and now every child can be told there's an attraction of mass that stops people falling off the bottom, and eventually they concluded there is no top or bottom, everything is attracted to the centre. This was the beginnings of the utter insanity yet to come. Now this force can be used to explain everything. Why does Earth orbit the sun? Gravity. Why does the moon orbit the Earth? Gravity. Why do clouds hang up in the sky? Density and buoyancy. Gravity. Why doesn't Earth crash into the sun and the moon into the Earth? Dark forces. Luke, my boy. Dark matter, dark energy. Use the force. So gravity is nothing but an extremely weak force. In fact, we're told it's not even a force, but we can think of it as one. Like thinking elephants aren't daisies, but we can think of them as daisies. This is the insanity of today's heliotards with their God of the Gaps gravity, which is easy to disprove as the child lifting a straw from a drink with their finger over the end and seeing the water stays in the straw. As it's lifted out, a tiny vacuum force is created in the air gap at the top of the straw, sufficient to prevent the liquid falling out. Remove the finger, gravity is turned back on. In every instance, the force of a vacuum far outweighs the pseudo force of gravity, but don't let that stop you from believing. It makes sense that since everything about gravity was given to us by priests, occultists, alchemists, and sun worshippers, that we should also believe in gravity on faith alone. But just imagine, if you will, and please look up afterwards a railgun projectile video, an object fired 8 times faster than the speed of sound, that a small to medium wandering star could shoot through a vacuum of space some 10 times faster than that projectile, spinning on its axis all the while, that this extremely weak pseudo-force called gravity is sufficient to hold onto miles-thick layer of gases, trillions of tons of magically curving water over 70% of its surface, huge cargo ships on every angle of the surface, and gently wafting clouds hovering in the air. And now you know why the very idea of it is utter insanity. Newton's first law states a body at rest remains at rest, and a body at motion will remain in motion, unless it is acted upon by an external force. This is the key to wisdom and truth. Imagine a hypothetical void of space with an object of mass in it. Any mass, doesn't matter. With nothing to rest upon, it will drop perpetually, possibly even accelerating infinitely, as there's no air resistance to cause terminal velocity. But it won't know it's dropping because there's no other object to compare itself with, the origins of relative motion. A thing is only in motion relative to another thing. But if we introduce another mass, and they're both dropping together, even they will be unaware they're in motion because relative to each other, they're still perfectly still. So what then if we introduced a base to this void and filled it with all manner of things? The properties of matter are basically described as solids, liquids, and gas. How would we arrange this base? Well, we'd say the more dense things would displace the less dense things until finding a place of sufficient density to resist them from dropping any further, where they'll stay at rest unless another force acts upon them. Therefore, we must conclude that the force is resistance. As the dropping objects first meet the least dense matter, the gaseous atmosphere, it eventually slows them to a terminal velocity. Now, let's say object A discovers itself to be a large flat slab which achieves terminal velocity well before object B, which discovers itself to be a large upright spike. Finally, they meet at the base, the place of the most resistance. Object A lands with a solid whump, but barely indents into the surface. Object B has virtually buried itself in the ground because it hit with a greater force. Is it correct to say the ground pulled on B harder than A? That's literally the conclusion the spinning spaceballers have to argue because their entire existence depends upon the attraction of mass. The logician, such as myself, will argue that the force of resistance prevented A from hitting as hard, and its shape spread the force of impact over a greater surface area. So Newton basically said they would stay in motion until acted upon by another force, and that force has to be resistance. How did the base come to be? There's many theories, such as in the beginning was the Word, and the Word was good, and the Word was God. Either way, here upon the physical realm, nothing can be built without a base. We may think of the scale of music, where higher notes go to lower notes. The lowest is always the most bass, the most dense in terms of frequency and vibration. The etymology of words can be very telling, no pun intended. The opposite of light is dark and heavy. Let there be light, then scale it down all the way to the base. You can't build a building without a base. When a sculptor creates a beautiful statue, he doesn't place it on the bottom or sides of a sphere to display. It needs a solid base. You cannot build a house without a base, flat and level. And the best, and also the most traditional way to determine level is with water. You don't build a swimming pool on the side of the wall. You put it in the ground because you know the properties of liquids is that they fill their container, creating a flat and level surface. Just as every river flows to the sea, you cannot claim gravity forces a stream up and over hundreds of miles of curvature to get there. They'll only ever flow from high to low, always seeking the next level. But the educated idiots amongst us will hold a globe in their hands, look at the Nile River, for example, traverse up and over some 2,000 miles of curvature hump from Lake Victoria to the Mediterranean Sea, and declare that the god of the gap's gravity can easily do that. Meanwhile, the logician studies the topography, discovers Lake Victoria, it's about 1.6 miles above sea level, and determines that it flowed downhill all the way to the lowest level, sea level. While this time, let's look at the moon. The force of gravity pulls everything to the center of the Earth, according to the faithful believers in it. But because Earth is apparently charging 10 times faster than a railgun projectile around the sun god, gravity causes the moon to fall around us and keep missing, then accelerate back around and miss us again and again, 12 to 13 times a year. Meanwhile, although this describes the incalculable, impossible three-body problem, they will say the gravity of the moon causes 2 tides a day, even though it only has one mass. The mathematicians of modern wizardry called science insist the force of gravity is proportional to the mass and the inverse square of the distance. Then, with a bunch of circular reasoning, insist the moon not only pulls one high tide towards it, it lets the water bulge away for the second high tide because it's not pulling the other side of the Earth towards it. Meanwhile, they'll say 2 bulges are permanent as the Earth rotates through its own oceanic bulges. The logician, however, argues that if gravity's force is proportional to the square root of the distance and the oceans are actually on Earth's surface, where gravitational force must be strongest, then even if the moon was capable of pulling a bulge of water facing it, with 1/6 of Earth's gravitational pull from almost 250,000 miles away from our surface, then wouldn't the inverse square law make Earth's gravity 1,000 times or even 1,000,000 times more than that of a distant smaller body so far away? Therefore, the side of the Earth facing away from the moon would have all of Earth's gravity pulling on it, plus the tiny weak force of the moon from the other side, thus creating an even lower low tide, than that which we regularly see occur twice a day between the 2 regular high tides. Gravity literally debunks itself by its own arguments. It just takes a logician to point out the obvious faults or call them out for what they really are, tremendous leaps of faith. I look forward to hearing my opponent's defense for 2 daily tides on his fantasy ball belief. Since I'm grounded in reality, I'll gladly explain how they work here on the fixed base of the observable universe, where everything finds its place logically in accordance with the observable law of relative density and buoyancy. Thank you.
Thank you very much for that opening statement, Iron Horse. Folks, if it's your first time here at Modern Day Debate, I'm your host, Dr. James Coons, and we are a fully neutral platform hosting debates on science, religion, and politics. We're glad you're here, no matter what walk of life you are from. And also, have to let you know a couple of quick housekeeping things. As you can see at the bottom right of your screen, Andrew Wilson and apostate prophet collide in North Carolina this coming Monday. You can get tickets in the description box below. Check out that link right now. If you're anywhere near Asheville, North Carolina, there's also a free ticket option. So pretty epic. Not only that, but you might be like, oh, that's cool. But I heard you were doing a fundraiser recently for camera lenses for that event. Yes, we are. So for these events, such as BaitCon 5, we rented these beautiful camera lenses and we were like, wow, these are really good. These work for us. This is what we should buy because we're going to be using them so often. It makes more sense to buy them rather than rent them. Ipso facto, check out the GoFundMe link in the description box to help us reach our goal to get all lenses needed for this upcoming debate. Time is running out. With that, we're going to kick over to PhD Tony. Thanks for being with us. PhD Tony, the floor is all yours. Oh, you might be on mute. Let me just double check.
Sorry, no, I turned my mic off while Ross was talking. Sorry.
You got it.
Let's start with what is gravity. Gravity is the attractive acceleration that acts between objects with mass. For extremely massive objects like planets, gravity produces a downward acceleration acting on all objects near the planet. How do we know that gravity is not just density buoyancy, as my opponent claims? We can measure the downward acceleration using instruments called gravimeters. We can control density and buoyancy effects inside our gravimeters. If the density and buoyancy within the instruments are held constant, but the direction and rate of acceleration are varied by moving the mass around the outside, then here's our instrument. We're keeping it constant. We're moving masses around it. If the mass distribution outside the instrument affects the reading of the instruments, then it can't be density and buoyancy inside the instrument that is the determining factor for acceleration. Here's an experiment. We have a superconducting gravimeter in a pit here. We apply a modestly sized human proof mass a meter above the instrument, and we look at the readings. The proof mass above the gravimeter reduces the downward acceleration. Here's a paper that is often cited by Austin Whitsitt, again using a superconducting gravimeter, and you can see the tidal modes here that are clearly delineated. The gravimeter is picking up the gravitational signature due to the motion of the moon and the sun. There is also a mass effect due to thunderstorms. Whitsitt, whenever he talks about this, claims that tides are not due to gravity. This single graph from his own resources shows that he's wrong. The most famous experiment that shows that masses can accelerate other masses is the Cavendish experiment. People often ask, has this ever been done in a vacuum? Yes, it has. Here, for instance, we're looking at Gundlach and Merkowitz's 2000 paper, where the torsion pendulum, which is that 1.5 millimeter thick slab of Pyrex, is located in an aluminium vacuum chamber and surrounded by mu metal. Mu metal is a nickel iron alloy that is designed to protect the apparatus from electromagnetic influence. Here's another experiment, Lee et al., more recent one. Both experiments here, on the right, you've got the angular acceleration feedback technique of measuring gravitational, and the other on the left, you've got the time of swing experiment. These apparatuses were located in a cave, in passive thermal rooms. They were shielded in vacuum chambers, and they were protected by aluminium cylinders. So yes, we have protected these experiments from other effects. Historically, how we came to an understanding that mass attracts mass in practice is because there are two ways of determining where you are on Earth's surface. One is surveying, and the other one is looking at the stars overhead. But they can, in some circumstances, provide different results. For instance, Bugay, in his trip to South America, to Ecuador, noticed a 7 arcsecond difference between the surveyed coordinates and the celestial coordinates of Mount Chimborazo. When they were surveying the Mason-Dixon line, Mason and Dixon noticed systematic errors in their lines. They didn't close properly, which they should in the absence of an error. Henry Cavendish suggested that this was due to the Allegheny Mountains, the gravitational attraction of the Allegheny Mountains. In the Great Trigonometrical Survey of India in the 19th century, observations at sites that were about 5 degrees apart from one another were off. The surveying techniques produced different results from the celestial techniques. So he went back and he checked. He propagated a fixed length over 200 miles. I think it was 200 miles, and found an error in propagation of less than 8 inches. So the surveying techniques were shown to be completely accurate, far too small. So the error comes about because when you use an azimuthal sector, it assumes that the plumb bob is hanging orthogonal to the reference surface, but they aren't. They are deflected. This result was confirmed in the Schehallien experiment, where a bob was observed to deflect towards the Schehallien mountain, consistent with gravitational effects. And when the bob was moved to the other side of the mountain, it was deflected the other way towards the mountain. This phenomenon is called vertical deflection, and it's well known in surveying. It has been known for hundreds of years, and anybody who claims to have any expertise in surveying and is unaware of gravitational effects on bobs is just lying. We can also look at gravitational time dilation. If Ross is correct, then gravity cannot have any effect on clocks, except that Einstein predicted that gravity does have an effect on clocks. Here's an experiment from the early 1970s where 2 atomic clocks were placed on planes, one flown eastward around 2 circuits of the Earth, the other flown westward. And when they joined up, their differences were compared. You can see the eastward one there in the left-hand column of that graph on the right, and the westward one. And you can see that the observed discrepancies well agree with the theoretical predictions. A similar experiment, except stationary, was done with 2 atomic clocks in the Tokyo Tower. And you can see in that red graph and blue graph that the blue graph, the higher clock, is running slightly faster than the red clock. Again, a demonstration of gravitational time dilation. We can measure this on smaller timescales. In this case, we had 2 atomic clocks and we moved one up by 33 centimeters. And we observed a consistent gravitational time dilation. A third experiment uses an atomic clock, a cloud of 100,000 strontium-87 atoms in a Bose-Einstein condensate. We look at the electron transitions in the cloud, and we can see that there's a gradient. When we plot up the gradient on the right, we see that it agrees very closely with the theoretically predicted value. Flat earthers often claim, why do helium-filled dirigibles, balloons float? And the answer is for the same reason that helicopters fly, the same reason that planes fly, the same reason that rockets take off, and the same reason that weights leave the ground. In all of these cases, there is a downward force due to gravity, and there is an upward force applied to the body. If the upward acceleration is greater than the downward acceleration, the body moves upwards. The same is true for a dirigible or a balloon. Just because buoyancy exists and the buoyancy acceleration is larger than the gravitational acceleration doesn't mean that gravity has ceased to exist. Another question that they asked, and I can't believe adults really think this, is how can gravity be strong enough to hold down all that water, but weak enough so that butterflies can fly? Newton's second law, Newton's second law says that force is equal to mass times acceleration. It takes more force to accelerate a more massive object. It takes very little force to accelerate a butterfly because butterflies aren't massive. It takes a lot of force to accelerate an ocean upwards. How do we know that gravity is not caused by electrical fields? Quite simply, neutrons fall under gravity. Here's an experiment demonstrating this from 1965 where they shot a fast stream and a slow stream of neutrons over 180 meters and detected their arrivals at the far end and found results consistent with them falling under gravity. More recently, we can use very, very low velocity neutrons fired into this apparatus, and we can very accurately model the quantum capture states that they're going to be in. Consistent with them being under gravity. Why does this dispel the claim that gravity is electric? Because we've never seen an electric field, regardless of how strong, have any effect on the motion of a neutron. Here are 8 experiments on us trying to detect the deflection of neutrons. It doesn't happen. We use gravity in the real world. Most significantly, for more than 100 years, we have been using gravity to find mineral deposits under the ground. This cannot be explained by density buoyancy because we are detecting the influence on the acceleration of proof masses or on our detectors from stuff that is under the ground, from stuff that is not near the instrument. Here is the first mineral deposit that was discovered using gravimetric techniques. This is the Nash Oil Dome in Texas, which was found more than 100 years ago. More recently, here's a gravimetric survey. You can see that blue sector in the middle. That is a less massive portion, possibly gas, possibly oil. But with these results, mining companies know very accurately where they should be drilling in order to find these deposits. Mining companies spend a lot of money having gravimetric surveys done so that they know where mineral deposits may be found. Real-world application number 2 is passive submarine navigation. If submarines were always using their sonars, they'd be very easy to detect by ocean floor sonar, by other submarines, by surface craft. So from the early 1960s, a lot of effort has been put into how to navigate a submarine so that it doesn't crash into the ocean floor without using sonar. And what they ended up using in the first instance were gravity maps. They would map gravitational acceleration and they would use the characteristics of the gravity map to work out where they were and where they were going. More recently, they've moved on to using gravity gradients, which was a technique they developed in secret, but is now used quite prominently in mineral exploration. Real-world application number 3 is ocean floor bathymetry. It turns out that the mass of underwater mountains cause bulges in the water. These are detected by satellite altimetry, and the result is these maps. You can detect this yourself if you go to Google Earth. If you bring up a bit of the ocean, you'll see what look like snail trails, these very crinkly, thin, straight lines. That's where the ocean floor has been surveyed using sonar. The rest is from gravitational surveying. So here's an example of a portion of seafloor that was surveyed during the MH370, and we can see on the right, that's the sonar survey result. On the left is what it looked like before when we were just using gravity. And you can see that the gravity is muddier. It's lower resolution. The sonar does a better job. But gravity provides a very cheap way of getting reasonably accurate results. You wouldn't say that the graph on the left is wrong. It's just out of focus. How much time have I got left? Okay, then I'll stop there.
With that, we will jump into the open dialogue. But first, a couple of other quick housekeeping things. Folks, I have mentioned before, we have that Lens fundraiser. Thanks very much for the $5 donation. And not only that, but we'll have, after this open discussion, Q&A, as always, where we will read the super chats first. And then if you want to submit a standard question, you can tag me with @moderndaydebate. And if you put in a donation to the GoFundMe linked at the top of the chat, and that's at the top of the description box, that's another way that we can read your super chat. Just let me know, like, hey, it was me who just put that donation in, and we'll read your question straight from the chat here on YouTube. One last little note is, folks, there are so many big things coming up. Look at the bottom right of your screen right now. Atheists for Liberty. Our friend Thomas Sheedy is hosting an epic debate between Destiny and Andrew Wilson. It's going to be on May 6th, 7 p.m. It's going to be in Knoxville, Tennessee. You don't want to miss it. Modern Day Debate is sponsoring this event. Tickets are linked below in the description box. Highly encourage you, show up in person. It's going to be a massive debate. And with that, we're going to kick it into open dialogue. Thank you very much. Gentlemen, the floor is all yours.
So to clear up Ross's
my first
misunderstanding
question
of
for
how
you, Tony.
tides work. Sorry, you can go
I think it's
first.
just a
I have a
delay.
question for you.
There might be a slight
right.
delay. Let's go with
I
Tony's.
had a question for Tony.
Let's go with
Okay.
1 second. Let's go with Tony's question first, and then Ross, I promise we'll go to yours right after. I think what we're getting is just a bit of a delay with the connection.
It's
ahead,
not
Tony.
so much a question, it's an explanation. So the bulge on the second tide that is often but not always observed in tides is because the planet is pulled away from the oceans. Also, if you look at the force balance for the water on the far side, the force normal to the Earth is along the line of the attracting object is absorbed by Earth's surface. And the remaining component of force is normal towards that second bulge. So when you do a force diagram of what's acting on the other side, it produces a second bulge on the far side. So the claim that the second tidal bulge is inexplicable is not true. Also, we observe tidal effects using precise gravimetric readings. So we can directly measure tides and we can compare them to our theoretical calculations and we get very accurate results. So there's no reason to believe that our models of gravity are wrong.
Okay, well, that's completely illogical because if you're going to pull the Earth away from its own oceans, where the Earth's gravity is the strongest, the oceans itself would come with it. You can't pull the Earth away from its own oceans. And if you did do that, you'd get closer to the moon and you'd be nullifying the first high tide facing the moon in the first place. I don't know how you can even argue that as an actual valid point using gravity. It's absolutely nonsense. You can't even pull water in the first place. Water cannot be pulled. You can only pull the container of the water. No force will pull water, but you can easily repel it.
You're just making assertions with no evidence other than you say so.
Oh, rubbish. I can easily prove it.
I didn't interrupt you. Do you want to behave or not?
I can easily prove it that you cannot pull water. I'm not interrupting you. You gave a pause. You asked me a question. So I'm going to answer your question. You cannot pull water. If you hold a straw above a glass of water, doesn't matter how strongly you suck on that straw, if it's above the water, you will not budge it. But if you blow gently, you can easily repel it. And that's how we have tides on our stationary planet Earth, because the moon repels the tides. You cannot pull water. So gravity sucks.
So is the moon blowing air on the oceans? Is that what's happening?
No, it's having a diamagnetic repulsion effect upon it.
Except that it can't be a diamagnetic. So then why is this picked up in a gravimeter?
I don't even know what a gravimeter is. It sounds like a fancy name for a fancy device that says nothing.
Again, that's just an assertion. Gravimeters are high precision instruments. They use a variety of different physical operating principles, which I can discuss and explain to you if you want. But the simple fact is that just because you say, what to dissect your argument, your first argument was that if you pulled the Earth away, you're going to remove the lead bulge, except that the lead bulge is closer to the moon, so it's experiencing a larger pull than the Earth, which is experiencing a larger pull than the water on the far side. So you're not going to eliminate the bulge on the near side of the Earth by pulling the Earth away from the further bulge. Again, may I share my screen?
You bet. Ready for you.
Yep, just a moment.
Well, there's a quick pause. Obviously, the Earth's gravity is still going to be 1,000,000 times stronger than the moon's because the ocean is on the Earth.
That is certainly true. Yes, the Earth's gravity is much larger than the gravitational attraction due to the moon, but the gradient of the lunar attraction is applied over very large distances, and that gives it an opportunity to be detectable. So you asked about how gravimeters work. The most fundamental form of gravimeter is a pendulum. The length that a pendulum takes to swing backwards and forwards is a function of its length and the local value of gravity. It is not dependent on the mass or density of either the rod or the weight. And these were used.
Does this have anything to do with the moon?
You asked what a gravimeter was, mate. I'm explaining to you various styles of gravimeter that can detect tidal forces. So,
does it change during the phases of the moon or the time of the moon?
Here are some examples of pendulum gravimeters. Pendulum gravimeters have been used on submarines to detect gravitational anomalies. Here's a different style of gravimeter. This is called a drop gravimeter, where you drop a reflecting corner cube in a sealed, evacuated drop chamber, and you measure its fall with a laser. Here's some details. This is a cold atom gravimeter that uses clouds of Bose-Einstein condensate, which are propagated through a chamber and then recombined, and you look at the wave function. In this particular style, you're looking at the transition between the 3PO and the 1SO electron shells in strontium. This is a superconducting gravimeter. It consists of a niobium ball that is held in an electrical field. If any accelerations happen to the ball, it induces a current, pushing it back to where it came from in the feedback coil. These feedback currents are recorded, and that's what gives us our instruments. You can also have borehole gravimeters, which we stick down boreholes to measure at what depth gravitational anomalies are applied. That's a schematic. You can also, this is a zero spring gravimeter. This is a spinning gravimeter that measures the lateral components of gravity. And this is an interesting one because it completely refutes your claim. In this style of gravimeter, you have liquid quartz down the bottom in which there are two levers. So the damping liquid is quartz. You've got the pendulum lever. Both levers have mirrors attached to them, and they have a proof mass on the outer edge. That's the square thing. When that proof mass is deflected, that changes the angle of the mirror, which is picked up because there's a diode flashing lights, and you pick up the movements of the mirror because the lights have moved. Now, the density of the quartz is not changing. The density of the proof mass is not changing. So how is this picking up any gravitational signals?
Well, you're the one telling the story. Do you have to take into effect what time the moon is overhead, or when it's rising, when it's setting? and all that
You
sort of
do
stuff.
have to. You
Because
do
we're
have to.
talking about the moon's effect on gravity and the tides. We're specifically talking about the tides at the moment.
Okay,
And,
so evidence that your hypothesis is wrong is irrelevant because we were talking about something else. Is that your argument?
No, my argument is we're talking about tides, and you're trying to say that the gravimeter measures this effect. So I'm saying, well, obviously, anybody using one of these things, if they're highly sensitive instruments, they'd really have to take into account the position of the moon, wouldn't they?
Yes, and they do.
They do.
Yes.
Can I see the manual for where they take into account?
In the analysis phase of the data, they correct for tidal effects. Yes. So,
you said tidal effects, but you didn't say the moon. Like I can
there
tell
are
you
multiple
for a
tidal
fact,
effects, right? They take into account all of the tidal effects.
No, I'm telling you, you cannot pull water. Gravity will
And
not.
that's just an
water. It will
assertion.
not
That's
attract
just an
water.
assertion you're making, and I've got multiple data sets that tell you you're
I
wrong.
can prove you can't pull water. As I told you, with the simple experiment of using a straw above a glass of water, you cannot pull no matter how hard you suck on that straw. But if you blow on it gently, you can easily repel water. So it only takes a gentle repellent force from the moon to create the tides. And we have two of them every 24 hours and 50 minutes, which is coincidentally in phase with the moon when it appears every day. It appears about 50 minutes later than the day before, and the tides occur approximately 50 minutes later than the day before. And we have two of them a day. You cannot say that the moon is pulling the Earth when the moon is tiny and 250,000 miles away. It's ridiculous.
You asserting that something is ridiculous is not making it so. I showed you that we measure deviations in the surface elevation of the ocean caused by gravitational influence of underlying masses. So your claim that water cannot be pulled is shown to be false. Similarly, I could, if you're interested, show you that actually ice sheets exert a gravitational. Yes, I just did, mate.
No, show me an example
literally in
where
my
water
presentation, I showed you.
Be pulled. Show me an example where water. No, show me an actual physical example where water can be pulled where you're not pulling the container. You cannot show that.
You mean
it doesn't happen? It's illogical. It is
so you mean on the masses inside a laboratory, you want that demonstration?
No, I want it in reality, mate. We're talking about reality.
So what about a drag
laboratory.
chamber?
This is the problem.
What about a drag chamber?
With you people that do experiments inside a laboratory. I live in nature, man. I've been living in tidal places all my life, or most of it, and I've observed the moon, and the weirdest thing is the highest tides occur on the full moon as it's rising, not when it's overhead. It's actually repelling the water towards us. It's not happening when it's overhead, when it should be pulling it up or behind us and pulling the most water. It goes the opposite of what you guys say.
You'll find that the
highest tides you guys believe in is completely bass backwards to reality. You do it in a laboratory and you think, oh, yeah, well, show me gravity in a laboratory. You can't, because the Earth's gravity is always going to be 1 billion times stronger than any of those attractive forces in your Cavendish experiments or whatever. That if it had gravity, your Cavendish experiment would never work because the downward force would be way stronger than the tiny little attractive force of those bigger balls.
Are you done?
Did I keep talking?
Well, you did for about 10 minutes, so I just wanted to check because you might just be drawing breath before you pass out. Yes, these effects are relatively small, but they are detectable by instruments. You have been observing the natural system using instruments that we have had for 10,000 years. It will doubtless come as a surprise to you that in the past few hundred years, we have developed instruments vastly more sensitive and vastly more accurate than the human senses. That's what instruments are for. And using those instruments, we have come to a better understanding. Your claim that the highest tides occur during the full moon is false. highest tides occur during the new moon, don't they? When the gravitational attraction of the moon and the sun are acting in the same direction. That's when the highest tides occur. There is another high tide at the new moon, and that's because, as I said earlier, as when they're in a straight line, the tangential component of the force diagrams is at its maximum. So your argument that therefore the moon repels water is nonsense. The moon clearly attracts water.
That's not true.
You can say it's not
It's
true,
not true,
mate.
because I've tested this for you, Tony, and I've tested it multiple times.
Show me the data. Show me the data. Show me your data.
Sometimes, yes, we do get a king tide on a new moon, but you know what? That happens in the morning, at 9 o'clock in the morning in the river systems, because the river systems are generally about an hour or so behind the ocean systems. And at 9 in the morning, a place like Ballina, when it got its last king tides that I can recall coming up in the media, happened about 9 in the morning, whereas the king tides that happen on a full moon happen about 9 in the evening, because the sun and moon are opposite one another when that happens, but the sun and moon are together during a new moon phase. So the moon is obviously repelling as it's coming up, and then you get the king tide occurring in the morning. It should be happening at the time when the sun and moon are both overhead at the same time, which would be about 12 to 1 p.m. because of the tidal delay in the rivers. But it's happening in the morning.
No,
yes.
So no, because there is a thing called hydrodynamics. The ocean, the water cannot travel instantaneously to keep up with the moon. The water has to flow. This is a physical process that is damped by bathymetric effects. So no, the water does not respond instantly, and nor is it expected to. So the model of reality that you are attacking has nothing to do with the model of reality that is actually held. You are disproving a straw man, and maybe you should familiarize yourself with what mainstream science actually says rather than what you think it says.
Well, that's exactly what I agree with you. It's a delayed effect because it still happens at 9 in the morning, where the sun has come up about 6 or 7 in the morning. So it does take a little bit of a while because of the fluid dynamics and the whole effect of the fluid dynamics delay, and eventually it gets there. So I agree with you. Yeah, there is a delay.
So that isn't a disproof. That isn't a disproof of the tidal model, then, is it?
Absolutely.
Why?
Because if it's a repellent force, it's pushed the water ahead of it, and then when it arrives and then it goes overhead, it pushes the water back away again. So by the time it's overhead, it's going to be a low tide because it's repelling the water. It's not pulling it.
If it were repelling the water, then shouldn't the high tide occur at midnight when the sun and the moon are furthest away?
The sun has no effect on the tides. It's all the moon.
That's absolutely untrue.
It's absolutely true, because they always occur 50 minutes later per day.
Please show me.
With the way
please show me
work.
your evidence that the sun has no effect on tides. I'll accept any textbook reference. I'll accept any scientific paper you can show. Or are you just saying that the sun has no effect on tides?
See, this is the problem. You only accept something if somebody else has done it.
I'm not accepting something just because you say it.
That's right. I don't care. But I can tell you, I have personal experience with it. I've had decades of personal experience with it. I've been using a moon chart for decades, and I've been observing the tides twice a day in nature myself, not in the classroom, not from a book, out in reality. And so I know what I'm talking about. You don't.
Can you show us your calculations of when? Can you show us your calculations of when? I'm not going to let you filibuster. Can you show us your calculations of when high tides occur and how big they're going to be? So your predictions, please show us your theoretical predictions of when high tides occur and how big they're going to be. And then we can test the accuracy of your understanding versus the accuracy of the scientific community's understanding, right?
It's not like I'm going to spend all day sitting out there taking recordings of what I observe every day.
Okay, but the scientists who have taken the trouble to make recordings, who have instituted tide gauges, they're wrong because they bothered to look at the data and you couldn't be asked to look at the data.
The data matches observations.
How would you know? You have no data.
Excuse me, it was my turn. I was just going to say something. For years, as I'm watching the tides and I'm watching the moon phases, and I've got my moon calendar, which I have all year round, and I'm watching the phases and the times and when the eclipses are, and all that stuff is going to occur. When I go out and watch the tides, and then when I watch the moon, nothing made sense. None of it made sense whatsoever. But as soon as I realized that the moon was repelling the water, not attracting it, everything fell into place. It makes 100% sense.
So we should believe you.
The lesser high tide behind it, the major high tide in front of it.
So we should believe you because you think it makes sense.
Yeah, because it makes observational sense with my years and years of observations in nature.
That is not in any sense quantified, nor in any sense formalized. So the people with the formal data who have actually bothered to take measurements, we shouldn't listen to them. We should listen to you because you've spent a bunch of time outside looking at the moon. That's why we should listen to you. Okay.
Absolutely.
Very persuasive. And we shouldn't listen to instruments that actually detect the gravitational attraction due to the moon and the sun. We shouldn't listen to those either.
There is no gravitational attraction. It's absolute bullshit.
We measure it in instruments,
mate. When I
mate.
watch the high tide approaching, when the moon's approaching to me, I think that's just an absolute anomaly. It should be occurring when the moon's gone past me overhead and dragging the water with it. But no, it's actually pushing the highest tide towards me as the moon is approaching.
You keep asserting that, and it's not true.
Okay, so you've got no answers. You can't tell me how we can pull water. My next question to you was, well, my first question, as we're going to start going back and forth, is what's a neutron? You said
a neutron is a subatomic particle that has a net zero charge.
Can we see a neutron?
No, you cannot see a neutron. Can you see air?
So how do you know they exist?
Can you see air?
How do you know they exist?
Can you see radio waves?
How do you know they exist?
We have demonstrated their existence. So we have demonstrated their existence through experiment. Are you denying the atomic model of matter?
Well, yeah.
Okay, so you're denying the atomic. So you're denying electricity.
No.
Okay, what is electricity?
What is it?
What constitutes it?
It's a dynamic force.
No, it isn't. Electrostatics is a field of study. You can have electrostatic fields.
Yeah, you can. And
okay, so it's not a dynamic force, is it?
Air, of course, but I can prove air exists just by simply lighting a candle and putting a glass.
Okay, let's go back to electricity. Let's go back to electricity. What causes electricity?
Sure. Well, definitely not gravity.
I'm not saying that gravity. You're saying that if I can't see something, I've got no reason to believe in it. Can you see electrons? No, you can't see electrons. So why do you believe in electricity? Well, electricity works. How do we know it? How do we do our calculations on it? Well, we've got laws regarding it. We've done experiments for it. The same experiments that resulted in electricity existing and being used by human society have also told us that neutrons exist. So you're rejecting neutrons, but you're accepting electricity. Why? What's the distinction between the two? Why do you reject neutrons and accept electrons?
I didn't say I rejected them. I'm just asking you what one is, because you used that as part of your argument to say you could detect them falling due to gravity.
Yes.
I'm saying, well, how can you if you can't even see them?
You can detect the kinetic energy of their arrival. using very delicate sensors. Just like you can detect air pressure by having a sensor for air pressure.
Yeah, which is also called density.
No, air pressure is not called density. That's why they're different words, mate. No, it isn't.
You can describe it as density, though. It's a change of the density of the volume of the air.
No, it isn't.
Creates that change.
No, it isn't.
Everything is relative density.
No, it isn't.
Everything is relative density.
You keep saying simple stuff, but the gas laws tell us. You can tell it. Well, have a look at the ideal gas law. PV equals nRT, right? So pressure is a function. Pressure is.
Why don't you just say it in plain English?
Okay, pressure times volume is the number of moles times the ideal gas constant times temperature in Kelvin.
Okay, it's still a little bit coded, but that'll do. You also brought up helium and hot air balloons.
No, we haven't finished. Using the ideal gas law, we see that density is in fact a function of pressure and temperature, right?
Right.
Okay, so it's not just pressure. Pressure is not the same as density. You need pressure and temperature in order to derive density, right?
Yeah, correct.
Okay, so your claim that pressure is just density is wrong, isn't it?
No.
Yes, it is.
It's a change of density. That's why we use the term relative density.
You can change density without changing pressure.
How?
By changing the temperature.
Rightio.
So your claim that it's just pressure is incorrect.
But you don't need gravity for any of this stuff, do you?
You do need gravity in order to supply pressure. The pressure inside the atmosphere is because the atmosphere is a hydrostatic fluid, which is to say that the pressure at any point is hydrostatic. It's the same. It's isotropic. It has the same value in any orientation, and it's due to the weight of the overlying air. And in order to calculate the weight of the overlying air, guess what? You use gravity.
Okay. Like, assuming then that I agree with you, my opening argument says that you think that we're hurtling 10 times faster than a railgun.
That's irrelevant. That's irrelevant to whether or not gravity exists, mate.
Absolutely relevant because
it isn't.
Determines the up and downness of everything. And so a falling object through the atmosphere has to be adjusting for all of those speeds at all times, as does the pressure of everything.
Except that we can calculate the acceleration. We can calculate the acceleration. We can calculate the acceleration of Earth due to its motion around the sun. It travels. It completes one circuit of the sun in about 3.15 by 10 to the 7 seconds. Let's write that down. 3.15 by 10 to the 7. Okay. We know that the sun is 1.5 by 10.
1 sec. Ross, if you can, let's just, Ross, I think it might just be that there's a delay. Let's let Tony finish. I think that sometimes your feed might be delayed, Ross, where you hadn't realized like Tony's talking. I want to give Tony a chance to finish. I'll come right back to you.
Okay. So we know that Earth's angular rotation is 2 pi divided by 3.15 by 10 to the 7 radians per second. We know that the distance to the sun is 1.5 by 10 to the 11 meters. We can therefore calculate the acceleration as r times omega squared, which is 1.5 times 4 pi squared times 10 to the 11 divided by 10 to the minus 14. So that's going to be about 10 to the minus 2 meters per second squared. So it's going to be very small. Also, we're in free fall around the sun, so the sun's gravitational attraction doesn't have an effect on falling objects in Earth's atmosphere. Yes, we can calculate all of this, and there's no problem. There's absolutely no problem with any of this. You haven't calculated it because you haven't bothered to. The accelerations experienced because of Earth's motion around the sun is small. We can calculate the order of magnitude of it. It's negligible. Next point.
Oh, you finished? I nearly had a nana nap there. Right. No, that's bullshit, because the Earth spinning on its axis at 1.35 times the speed of sound would have a different speed at every latitude, and it would change at every time of day because it's also going 86.8 Mach around the sun. So depending on what latitude you were and the time of day, things would have to fall at a completely different angular speed in every place at every time in order to create the appearance of falling straight down. Yet no matter where we are, whatever latitude, whatever time of day, if we shoot something straight up, it will come straight back down. How do these dumb objects know exactly which direction gravity is pulling them to create that illusion?
Except that objects don't fall straight down. I demonstrated that. I can come similarly. Ferdinand Reich in the early 19th century did extensive experiments with dropping heavy weights down a mine and demonstrated that there is an eastward force due to there's an eastward acceleration relative to the mine that is acting on these bodies because their rotational effect is larger than the rotational effect on the floor at the bottom. So that's been debunked. In my presentation, in my presentation, I showed that vertical deflection exists, which is to say that the direction in which a plumb bob lies is not normal to the underlying surface. We've known this for more than 200 years. If you don't know it, that's because you haven't studied it.
I've studied this extensively. Do you know about the Tamarack mine mysteries? Do you know about the Tamarack mine mysteries where they suspended plumb bobs a mile deep and they always diverged rather than converged? They expected them to get closer together towards the bottom because that's going to be closer towards the center of gravity. And that's one of the ways they were intended to measure the circumference of the Earth. And they found they always got further apart at the bottom.
That would suggest that there is a lateral density anomaly or mass anomaly either side of the experiment. Can you bring up this publication?
I've read the book on my channel.
Can you bring up the publication, please?
Secret of the Ages. There's very little put on the internet about it because it's one of those things.
Okay, so again, this is something we should believe because you said so. Okay, great.
You can look it up if you like. It's called the Tamarack Mine Mysteries, and there's very little data about it.
Okay, so if I find it on the internet, it's always right, is it?
Because it goes against the narrative. It sort of says we're on the inside of a concave ball, which started me thinking we might be living inside something, and that made sense. Because therefore, like when you swing a bucket of water around your head, around your arm, the water stays in because of centripetal force. So centripetal force is way stronger than gravity. The water doesn't fall out of the bucket when you're spinning it around. Well, why doesn't the water fall out of the bucket when you're spinning it around?
Yeah, that's with a high rate of rotation. If you to say no, that doesn't make any sense at all. Okay, to say that a particular instance of centripetal force is stronger than gravity is not to say that centripetal force as a rule is stronger than gravity. That doesn't follow. Earth rotates. Are
you insane, man?
Earth rotates at a rate of 2 pi radians every 86,400 seconds. Right? Again, we can do the calculation of how much of an effect that is going to have at the equator, and it's less than 0.3 of a centimeter per second squared. So the effect of centripetal force is much smaller, due to Earth's rotation, is much, much, much smaller than the effect due to gravity. It's less than 0.3%.
Have you ever been to the fair and you go on the gravitron ride? The way the
Yes.
gravitron works is it spins and the people get pinned against the wall because of centripetal force.
Yes.
That's how it works. So that could explain gravity if we were on the inside of a concave world. The way it spins would push everything outwards and therefore downwards. That actually makes far more sense than gravity pulling things towards it while it's spinning through a vacuum of space.
Except that we observe in laboratory experiments that mass does attract mass. So therefore, and we observe in using gravimeters. I presented several experiments confirming this. I can present 24 more if you're interested in those.
You showed me
I can present there are I'm in the middle of talking, Ross. So again, gravimetric results are used every day in mining in mineral exploration. We can see
they're detecting density.
No, they're not. They're detecting. Well, how does density affect what's happening in the instrument? What magical force is density providing from a remote distance that is affecting what happens inside the instrument?
Okay, you're either detecting rock or you're detecting liquid minerals.
But how? How am I detecting it? What influence is that having?
I don't know. I don't know how a gravitometer works. All I'm saying is that's what they're detecting is a difference in the density of the material.
Except that we can demonstrate that the mass of a kid over a gravimeter has an effect on the gravimeter.
A kid,
right? Yes, a kid. You weren't paying attention during my presentation?
Not particularly. No, it was a bit boring.
Okay, well, it was the third slide that I presented, so well done. And if you were less of a dick, I might represent it. But now you're just going to have to wander on in ignorance because I presented this evidence.
Well,
you ignored it.
Your strongest argument.
I beg your pardon?
Your ad hom is definitely your strongest argument.
It's not an ad hom, mate.
Messenger.
It's not an ad hom.
Mass attracts mass in surveying.
Yes.
Can you tell me how in surveying mass attracts mass?
There is a phenomenon called vertical deflection deflection of the vertical. Again, I presented this in my presentation as well. We've known about deflection of the vertical for more than 200. I'm still speaking. We've known about vertical deflection for more than 250 years. The Schehallien experiment, for instance, is an example of vertical deflection. The plumb bob deflected towards the mountain, regardless of which side of the mountain it was on.
Yeah, I'd definitely like to ask you about that, because if Earth's mass is like 1 billion trillion times bigger than that little mountain, how does that work?
Well, you'll notice that it wasn't pointing sideways. There was a very small deflection towards the mountain because, as you say, Earth is bigger. Yes, it was small, but it was detectable. That's why we use very sensitive measuring techniques, and that's why we do very careful analysis, is because we're detecting things that are very difficult to detect.
And when was this experiment done, and what instrument did they use?
Well, they used plumb bobs and, they used a variety of instruments. They used plumb bobs, they used extensive surveying, they used an azimuthal sector. You might want to stop talking while I'm answering your question. And it was done in the 18th century.
Okay, so people back in the 18th century, so that's the 1700s, using plumb bobs, measured a gravitational pull of a mountain that was greater than the Earth's.
No, that's not what I said.
Yes, you
did. Said, no, it isn't. What I said was they detected the gravitational pull in addition to the gravitational pull of the Earth. Nobody said that the gravitational pull of the mountain was bigger than the gravitational pull of the Earth. That's just you lying about what I said.
Yes, I did. No, the Earth would always pull it straight down. It would never attract towards the mountain whatsoever.
Well, the results of the experiment prove you wrong.
Magnetic forces. Well, Okay, so you just disproved gravity.
No,
A tiny mountain compared to the size of the Earth is stronger than the Earth. Gotcha.
no, that's at no stage what I said. You're just
It's exactly what you said.
misrepresenting what I said and attacking that
No,
instead of responding to what I said. What I said was
I'm analysing what you've said.
they detected a lateral acceleration much smaller than the acceleration due to Earth, but detectable towards the mountain, regardless of where the plumb bob was around the mountain. So they moved the plumb bob to various locations, and wherever they moved it to, they were able to detect that it was deflected slightly towards the mountain. At no stage in my description did I say that the acceleration due to the mountain is larger or indeed comparable to the acceleration due to Earth.
So, acceleration. Can you explain what's accelerating?
The plumb bob.
But it's on a string, isn't it standing still?
Yes, that can but that's just because the acceleration's even out. There is an acceleration due to the material strength of the string, and there's an acceleration due to the mountain, and there's an acceleration due to the rest of the Earth. Again, object permanence, Ross. Object permanence. Just because an object is stationary does not mean that there are not multiple forces acting on it. When a plane reaches its maximum altitude, that does not mean that gravity has gone away or that its lift has gone away. The lift and the gravity are in equilibrium. They are equal and opposite to one another. Therefore, the plane flies at an even altitude. Same with the plumb bob. The plumb bob is subject to multiple forces. It's multiple accelerations that end up cancelling one another out. That does not mean that the accelerations don't exist.
It does.
No, it doesn't.
It means they don't exist because they've cancelled each other out. There is no.
No, it means that there's no net acceleration. Ross, Stan, if you're sitting on a chair, there is a downward acceleration into the chair, and there is an upward acceleration from the chair. You're not moving.
Rubbish.
Does that mean that either of those accelerations has gone away?
That is absolutely rubbish. I'm sitting on a chair. As Newton said, an object at rest remains at rest unless another force acts upon it. Acceleration is a change of speed. I think you are literally insane, which is what I started saying in my opening statement, is that anybody that believes an object at rest is accelerating is insane. And you're insane.
I didn't
think that
say
I'm accelerating both upwards and downwards at the same time when I'm at rest.
You really need to listen to what's being said to you, because you persistently show an inability.
Accelerating in two different directions.
I was still talking, Ross. Are you going to shut up and listen to the answer, or are you going to prattle on? If there are two accelerations acting on a body and they cancel out, there is no net acceleration. But that does not mean that the individual accelerations have ceased to exist. If somebody were to come out behind you and yank the chair from under you, you would accelerate downwards. That acceleration has not gone away and does not go away. The fact that you can experience I'm still speaking. An acceleration is not a change in speed. I'm still speaking, and I'm not going to stop speaking just because you try and yell over me. An acceleration is not a change in speed. An acceleration is a change in velocity. And even if it is obstructed, it is still there. There is still a downward acceleration acting on you, even though it is offset by an upward acceleration. There is no net acceleration, but the individual accelerations still exist. And you can fail to wrap your mind around this all you want. You're just publicly embarrassing yourself.
An object at rest remains at rest unless another force acts upon it. So yes, if somebody came and ripped my chair out from underneath me, that would be another force, and then I'd have nothing to resist me, and I'd fall to the floor, which is a force of resistance, which is all we need to worry about.
It's okay for you to
talk over me, is it? I
Yes,
forgot
you
about
got
that.
nothing worth
So-
saying.
So, okay. So if I'm being resisted by the floor and the floor has density, then that's going to be the force of resistance. That's the only force that's going to resist me. Otherwise, I'd keep falling perpetually. If somebody pulled out the chair from underneath me, in your example, I would stop accelerating. You keep saying that would have a force of acceleration all the time. No, I'm not. I'm at rest. But if another force acts upon me, that might change that. It's so simple.
Do
Why
you
do you have to
apply
complicate
pressure on the
something so
floor
simple?
underneath you?
Somewhat, yeah.
Yeah. What's pressure?
Pressure is weight from the density of my mass.
Weight is a form of pressure. What are the units of pressure?
I don't care about the units.
Okay,
irrelevant.
pressure is force per unit area. If you exert pressure, you are exerting a force.
Technically, yeah, because you have weight.
Therefore,
Weight
there
of
is
the
an
mass, which is
acceleration.
density.
Therefore, even though you aren't moving, you are experiencing an acceleration.
Do you even understand what acceleration means? It's a change of speed.
No, it isn't.
means we're going
You've
from one
said that
speed to
multiple
another.
times. Acceleration is not a change in speed. It is a change in velocity. It's a vector quantity, and if you
That's
can't even
hilarious.
handle
That's
the
hilarious.
basics of science,
Velocity means speed, you fucking moron.
no, it doesn't.
Jesus.
Velocity is a vector quantity. Speed is not. Velocity and speed are not synonyms.
Am I listening to this from somebody who calls himself PhD something? Oh, holy shit. Velocity and speed mean the same thing, you moron.
No, they do not.
Yes, they fucking
I encourage you to go onto Wikipedia and look up velocity, because velocity is a vector quantity and speed is not.
Okay. You got me there.
Acceleration is a vector quantity. It is the change in velocity, but you can be subject to multiple forces at the same time. And if the forces cancel out, or if the accelerations cancel out, there's no net movement, but the forces are still there. The forces don't vanish. And it's
So
like
therefore you're not accelerating,
you said something.
you're not speeding up, you're not slowing
I'm still
down.
speaking, mate. You said something about if somebody yanks a chair.
Hold on,
if
I do.
somebody
Ross,
yanks a chair.
go ahead, Tony.
Pardon me.
If somebody yanks a chair out from under you, they've applied a force to you. No, they've applied a force to the chair, and the force is not the direction in which you fall. They've applied a force at 90 degrees to that. So the force that they've applied is completely irrelevant to the direction in which you fall. You fall down because that downward acceleration never went away. It was just opposed by an upward acceleration due to the material strength of the chair. The accelerations haven't gone anywhere. They've just cancelled out. That's why you exert pressure when you walk.
No, I think,
when you sit.
If somebody tried to pull my chair when I'm sitting on it, I would actually move with the chair. So, yeah, that if I was trying to sit down on the chair as they pulled it out from beneath me, that would definitely make me fall to the floor. But if they pulled the chair, I'd go with it. Because my weight,
they pulled
my
the chair
density
out from
sitting on the
underneath
chair
you,
had the force of resistance underneath me, and somebody applied another force, I'd still move with the chair. I don't know what you're talking about.
people can pull chairs out from under people fast enough that they don't go with the chair, to overcome the frictional force.
Oh, do they really?
The chair.
Okay. Have you got a YouTube funny video of that happening? Because I've never seen one. I watch a lot of funny YouTube videos, and I've never seen that happening where somebody's sitting on a chair and have the chair pulled out from beneath them. That's just ludicrous.
You ever seen the magic trick where a magician wanders up to a table with a tablecloth on it and yanks the tablecloth out from under the dishes on the table? Same thing.
That's a completely different scenario.
No, it's not a completely different scenario.
It's being pulled fast enough.
Yes, exactly. And if you pull a chair out fast enough, the person will not go with it.
That's rubbish.
But that's well.
Absolutely.
Well, your expertise on rubbish is pretty outstanding.
Nonsense. All your things are theoretical
let's get
nonsense.
back to the topic at hand. Let's get back to the topic at hand.
Okay.
You claim that gravimeters don't measure some magical force that you can't describe or quantify. You claim
It's called
that
density.
it's called density. What are the units of density?
Yeah, need units of density. It's just a change.
Okay,
It's a difference of
density is
density.
not a change. Density can remain fixed.
It is. No, I can prove it.
How?
Do you want an example? Okay, I'll give you an example. You got a rubber ball and a lead ball, and you drop them from a high bridge. They will hit the surface of the water from the high bridge at exactly the same rate because relative to the air, they have the same density. But when they hit the water, the rubber ball will come back up to the surface and float because of buoyancy. The lead ball will keep on sinking. However, let me continue. You take that lead ball and you beat and roll it flat and shape it into a boat that has the same mass, the same density, the same weight as it always had, and yet now it floats on that same water. So relative density explains how it works. How does gravity change just because you've changed the shape of the matter?
Well, I'd like to say that your argument is self-defeating because you admitted that you didn't change the density of the lead. So the density argument doesn't work, floats. And it's the reason changing the shape floats, changing shape causes things to float, is because it changes the volume displaced by the object in such a way that the mass of the displaced matter is equal to the mass of the supporting object. Also, earlier in your explanation, you claimed that the mass of the lead ball and the mass of the rubber ball is the same relative to air. Would you care to expand on what you meant by that?
Yes, because
density and rubber don't have the same density. Sorry, lead and rubber don't have the same density.
That's right, because it's the resistance relative to the medium. So the medium of air has the same resistance factor to both, but the resistance factor of water is different because of the relative density.
Yes, but this is like saying so you've gone from a medium in which buoyancy effects aren't important into a medium where buoyancy effects are important, therefore gravity has stopped existing. That's not a valid syllogism. Right?
It is.
There are two forces acting on both balls all the time. There is an upward force due to buoyancy, and there is a downward. Even though they're heavier than the air, there is an upward force due to buoyancy and a downward force due to and a downward acceleration due to gravity. The same thing happens once they're in the water, except now the buoyancy effect is larger. That's all that's happened. So you've moved from one medium in which buoyancy effect. I beg your pardon? Well, except that it doesn't explain. It doesn't explain why the kid on top of the gravimeter affects the gravity measured by the gravimeter, does it?
I don't know anything about any kid on a gravimeter, mate. I'm just talking about the balls.
I explained it to you earlier. If you weren't paying attention, that's your fault, not mine.
Okay, but we're talking about.
We're talking about the evidence that I produced in this.
Where we drop balls off a bridge and we see what happens when they hit the water at exactly the same time because they both had the same air resistance. But when they hit rubber and
steel don't have the same air resistance and they won't hit at the same time.
The medium.
Rubber and steel do not have the same air resistance. Actually air resistance is a function of mass. So the heavier object is going to experience the heavier object is going to experience less resistive force due to the air, and the lighter one is going to experience more. So that argument is wrong. They're not going to hit at exactly the same time.
They do.
No, they don't. And where's your evidence that this happens?
They did
Show
these
me your evidence
experiments
then.
off the Leaning Tower of Pisa many, many years ago when they
There were
thought
no
that the most
experiments from the
heavy
Leaning
object,
Tower of Pizza. That's a myth.
they thought that the more heavy object would hit the ground faster, and then they proved that they don't. They always hit the ground at exactly the same time. You can throw off a massive steel ball and a tiny little marble, and if you drop them at the same time, they'll hit the ground at the same time because they're both experiencing the same amount of air resistance. It's got
No,
nothing
they're
to do with the
not.
attraction of mass. Yes, it
No, they're
does.
not. And so
100%. You were
so
wrong.
to
I thought
so
you
to
were the
dispel
PhD.
this,
You should
so
know
to
this.
dispel this, Galileo never did that experiment. Other people tried experiments at the same time, and the proposed
said
experiments
Galileo.
this proposed experiments used balls of uniform density but different sizes,
Yeah.
in order to get different mass. So they hit at the same time, regardless of the mass, but their air resistance was also the same because they were made out of the same substance. So the claim that air resistance is the same between rubber and steel is absolutely not supported by this. There was no experiment at the Leaning Tower of Pizza, so appealing to it as though it supports your argument is false. And again,
It was
you're
just an
talking.
example.
It's just an example that didn't exist. So maybe you should use an example that
Okay.
exists.
Well, okay.
You're claiming
Let's
something.
say we did it today. Let's say we
Okay,
did it
well,
today.
go
We
out
go to
and
a high
film it, and
bridge,
then show me that they hit it and drop it from
and we take,
drop from 150 meters and show it to me. But you claiming
so
it
let's say we
is
go
not
to
sufficient to establish it as real.
Let's say then we go to a high place, a high bridge, and we take two lead balls of exactly the same mass, and we leave one as a ball, and we flatten out the other one and turn it into a sort of an upside down cup, and we drop them both at the same time. Which one do you think is going to hit the ground first?
The solid one.
That's right, because of the air resistance. But
yes,
if they
the
had
existence.
the same air resistance is the force. That's all there is. You don't
no, it
need
isn't.
gravity.
So
you don't need an attraction. You only need an attraction of mass because you want to believe we live on a spinning space ball. That's the only reason you need to have this attraction of mass. Everything that we observe in reality has density and resistance from the medium that it lives in.
then why were the plumb bobs attracted to the mountain?
They weren't attracted to the mountain.
The experimenters disagree. So why? What error did the experimenters make?
Wind.
No, they made sure to shield the apparatus from wind.
You can't shield the wind.
Yes, you can. You can put it inside a shed, for instance. How windy is it in your house at the moment?
It's actually quite pleasant today.
I asked how windy it was, but they put it in a shed to separate the apparatus from the wind. Furthermore, that would require that the wind is always. Furthermore, that would require that the wind is always blowing towards the mountain, which is not physically plausible.
There's many different effects that could be attributed to that.
Okay. So why did the Cavendish experiment illustrate mass versus mass? Why has that experimental result been validated many thousands of times since?
Well, obviously that dude had to put it in a shed and observe it from a telescope, looking through a window in his barn or whatever.
So because the experiment's delicate, it's wrong?
I'm not saying it's wrong. I'm just saying that the mass would never attract the smaller mass if the downward force of the entire Earth is what it is. It would just leave them hanging there. It's just saying that something that's in motion will stay in motion until it comes to rest against something. And so even a torsion bar is eventually going to attract enough motion from the air molecules themselves moving that they will eventually come to rest against something. It doesn't prove gravity.
Except that we've done the same experiment in vacuums. So what's your explanation now?
Again, it'll be the same thing. The thing was never fully at rest. eventually.
Except we can demonstrate that it was, and in fact we take precautions against mechanical forces entering the apparatus. That's what the magnetic dampener is for.
You can't do it. You can't, because
that's your claim.
Remove whatever. Whenever you remove whatever method you're using to keep it still, you're still going to create some sort of kinetic energy that will make it eventually move somewhere.
And it just happens to always agree with the predictions of gravity, does it?
Well, which way does it go, left or right?
It depends on how you move the proof masses.
Exactly. So a thing in motion will stay in motion until acted upon by another force, and then it will come to rest.
Yes, except what's acting on the pendulum?
Motion.
How?
What pendulum are you talking about now?
I'm talking about the pendulum from which I'm talking about the pendulum in the experiments.
I thought we were talking about.
No, I'm talking about the same. I'm talking about the same experiments that I described earlier in my presentation that you weren't paying attention to.
So a torsion bar is a pendulum. Gotcha.
Yes.
No, it's not.
Swings backwards and forwards at a rate. It swings backwards and forwards at in a regular and analyzable rhythm. Yes, it's called a pendulum. If you were paying attention to the papers that I showed earlier, you would see that it was called a pendulum.
A torsion bar is a pendulum.
No, I'm saying that the experiments that I showed you earlier used pendulums, which were slabs of silicon suspended from fused silicon wires.
Fused silicon wires?
Yes.
Like glass?
They call them fused silicon.
Who are they?
The people who did the experiments, which you could have read because I had the reference. I had the reference up there for you to read, and you chose not to.
Okay, maybe we should. I read a few questions down. Stars above our heads, you said, proves mass attracts mass.
No, I never said that.
You did. I took.
No, notes. I didn't.
I took that after you said.
No, I never said it.
It's my second note. I wrote stars above our heads.
Your inability to understand English is not my problem, mate.
Okay, well, we can rewatch your introduction, but you definitely said that. Otherwise,
no, I didn't.
Written it. Okay, so
can you that's right. You wouldn't have written it unless you were delusional.
Okay, well, let's bring it back to Earth then. And can you tell me then, if the Earth is moving 10 times faster than a railgun projectile, and the ISS, for example, is only going 17,500 miles per hour, which is only about Mach 3, I believe, how does it orbit us every 90 minutes?
This question is unrelated to gravity and is off topic. You're trying to
gravity.
Also the ISS only. Also, the ISS only moves
all orbital motions are due to gravity. Everything that orbits us is apparently due to gravity. All satellites orbit us due to gravity.
Yep.
So absolutely. I need to know how satellites orbit us due to gravity if we're accelerating one particular direction, and these things are just free falling around us, but they orbit us.
Do you see this pen? It is moving around the sun with the same velocity as the Earth. I drop it. It continues to move around the sun with the same velocity as the Earth. Same's true of ISS. I'm now moving the pen backwards and forwards relative to Earth's surface. It's got that motion, but it's still moving around the sun with the same velocity as Earth. The same's true of the ISS. The ISS travels at Mach 3 relative to the surface of Earth. The ISS travels at Mach 3 relative to the surface of Earth, but it is still traveling with the Earth around the sun. So if you were to take a reference frame centered on the sun, you would see that in fact it's traveling at at times at Mach 20 and at other times at Mach 14.
Yeah, right. So it's constantly accelerating and decelerating. So changing
Yes.
speed.
I beg your pardon?
Ah, wow. We've had a doctor finally admit the truth of what it must be. So do you understand the third body problem of how
Yes, I
the
do.
thing has to be, and how does this thing do accelerate and decelerate
Well, it changes.
in a vacuum?
It is so the acceleration is the apparent change in velocity only exists from the frame of reference of the Earth, of the Sun. Sorry, from the frame of reference of the Earth, it doesn't really change in velocity. It does a little bit because orbits are elliptical, but the acceleration is gravitational. I don't see what the problem is.
I do see the problem because you've just said you call it gravitational, but as I've said, that's the most fictional force that doesn't exist, that we can easily prove doesn't exist by the
Well,
simple fact of holding a finger over a straw and lifting it out of a glass of water. And that tiny little vacuum force at the top of the straw is going to stop the water dropping out. Gravity is not a force.
there's no such thing as a vacuum force. What is keeping the fluid in the straw as you draw it up is actually air pressure acting on the outside, acting on the fluid around the outside. There's no such thing as a vacuum force, and the fact that air pressure is pushing that liquid upwards does not mean that gravity has stopped to exist. Just because there are multiple forces acting on a body or a mass does not mean that gravitational acceleration is no longer affecting the mass. You can trivially, I'm doing it now. I'm applying a force larger than, well, yeah, an acceleration larger than gravity to this pen. Look at me go. Wow, mysterious. It doesn't mean that gravity has stopped existing. Your objection is fatuous.
So when I lift my finger off the top of the straw and the water falls back out, does that
You
turn
have
gravity back
removed,
on?
the air pressure above the fluid in the straw and the air pressure around the outside are now equal. There's no difference in pressure, so the gravitational force becomes dominant. The pressure
So
gradient,
gravity is air
remove the
pressure.
pressure gradient.
So gravity is air pressure. Is that what you're saying now?
No, that's not what I'm saying. Your ability to understand
It sounds
English
like it.
well, it sounded like it to you.
Yeah,
That's
it
all I can
does.
say.
It sounds like to
Well,
me that
your
everything has
inability, again, your
a
inability to understand
relative
the English that I
density
use is
relationship to one
more a
another.
criticism of you than it is a criticism of me.
No, I'm just saying that everything has a relative density in relationship to one another, and the vacuum force is actually very, very strong. It's the strongest force you could imagine. If you make a vacuum chamber, and as soon as you release the valve, the air is going to instantly want to enter. Now, you could describe that either way, as either the vacuum is sucking the air in or the air pressure is forcing itself in. Either way, it's exactly the same thing, and it's going to happen no matter what. So if you're going to say that we're on a planet hurtling through space, there's no way we could be hurtling through a vacuum and have air pressure unless we're contained. Now, if we're in a giant ball, that might work, but then why don't the constellations ever change? You know,
They
it's
do
just
change,
ridiculous.
but this is just a
Everything
this is
they do
now
not
switching.
change.
Yes, they do. They demonstrably do.
No, they do not.
Hipparchus's star charts show that they change. If you get up on March the 22nd and you look for the zodiac sign above the horizon, which should be Aries, according to the zodiac system that the Babylonians inserted, but it isn't. You'll see Pisces instead, because the stars do move. You'll find that
It's still
Scorpio
the
is really
same constellation.
Scorpio is not really in the zodiac anymore. It's largely been replaced by a constellation called Ophiuchus. So we can tell that stars move. We can see the proper motion of Barnard star in real time. We can see it moving.
That's one
I'd say
individual
real
star.
time. You take it, pardon?
That's one individual star out of the trillions that we see. Okay, thousands. And the constellations themselves
But this is,
remain
again,
constant.
this is
It should
irrelevant.
be
This
every
is irrelevant,
star of
mate. This
every
is irrelevant.
constellation that should be changing, not
This
the
is
constellation's
irrelevant. This is
position.
irrelevant to the topic we're discussing, gravity. You
You
asked to
brought it
talk
up.
about gravity.
You brought it up.
I didn't bring it up. You brought it up.
Second note I took, stars above our heads.
The stars above
You
our
brought it
heads
up.
are one of the techniques that are used to determine where we are on Earth's surface. But there are persistent imprecisions in that, in using azimuthal sectors in which stars go overhead because of gravitational deflection of plumb bobs. That's what I said. I didn't say that stars.
Okay.
I didn't say that stars cause gravity or that mass attracts mass because of stars. And maybe you'd have an easier time arguing against my positions if you had bothered to listen to what my positions were.
I was listening to them.
No, you weren't.
No idea. Okay, well, maybe you could listen to my position where I say that the Earth is the physical base of the universe, as I said in my position in the opening statement. And we watch the stars rotate, seated in heaven, rotating around above us as a singular body. And of course, they go in sidereal time, which means they go about 4 minutes faster per day than the sun. And this is something that I think you really should understand, is that the sun moves around above us in exactly 24 hours per rotation.
No, it doesn't.
Because that's the thing we measure a day by. And that's why every single day, if you set your clock by a solar, what do you call it, sundial, every single day, midday would match. The sunrise and sunset times are irrelevant because it changes, because it's moving in and out from tropic to tropic throughout the year to create the seasons. But every single day, no matter where you are, if your sundial is set exactly to 12 p.m., it will match. That's proven. So
no, it isn't. That's just a lie.
We cannot possibly be the thing going around the sun. The sun is what's going around above us.
That's absolutely untrue. And let me just present the evidence for that.
It's absolutely true.
So may I share my screen again?
Well, you have to present evidence. Why don't you just argue it? Why don't you just tell me in words?
Yeah, because evidence actually matters, mate. You said like all arguments should be legible to 12-year-olds. No, actually, you can try explaining quantum mechanics to a 12-year-old. They're not going to get it. You can try explaining relativity to a 12-year-old. Your average 12-year-old isn't going to get it. So
that's because they've been raised on modern education. But me as a 12-year-old, I'd probably understand anything if somebody dumbed it down enough for me.
Yeah, it'd have to be pretty heroic level of dumbing down, but
Not
whatever.
Really, no.
You've shown a systematic failure to explain. You've shown a systematic failure to understand what I'm saying in English, which is presumably your natural language.
It's the only one I know, actually, except for qu'est-ce que c'est?
Right.
I understand that. I think it means what the fuck?
No, it doesn't.
Comment-vous?
While Tony looks for that, do want to give you a reminder, folks, we have so many upcoming events. As you have seen at the bottom right of your screen, Andrew Wilson will be taking on Apostate Prophet. That's happening this coming Monday in Asheville, North Carolina. Tickets are linked below. There's a free ticket option. So they have university funding. Good for them. They can offer a free ticket option, which is cool. That's good for you. So check out that link below. We're ready for you, Tony.
Okay, so using high precision laser gyroscopes, we can detect changes in the length of day of the world. Here, for instance, is a measurement of how long it takes to, Earth's rate of angular motion through time. It is not constant. It varies. It varies through the year because of Earth's variation in in speed as it goes through its elliptical orbit. It varies on a 2-week cycle here are the length of day measurements. It varies on a 2-week cycle because of tides acting on Earth's bulge. So here are length of day measurements in how long it takes for the Earth to return to a particular position. So the claim that the Earth rotates in exactly 24 hours is just not true, and is based on an ignorance of the data relating to this subject. So are there any other falsehoods you'd like to share, Ross?
Well, I actually have a 24-hour, pardon me, 24-hour clock, and I've been testing this now for the last. I've been testing this now for the last 3 years, and the hour hand rotates once every 360 degrees. So if we were going around the sun, then we'd be changing by about a degree per day. So after about 6 months, my clock should be telling me that it's now 12 midday at 12 midnight.
And it does relative to sidereal time, right?
No, there's nothing to do with sidereal time. This is just a mechanical
clock. It has everything to do with sidereal time.
And the Earth is going around the sun.
Yes.
It's a simple logical deduction that you cannot prove any other way, because sidereal time has nothing to do with it. It's a 24-hour clock. It's mechanical. It's fixed. It measures 360 degrees every 24 hours. But if we're going around the sun, then it
you
should be
just
telling
made
me
the
that
argument that the
24
hour between sun positions is not actually how long Earth takes to complete a rotation. You just made the point that a rotation relative to the stars takes 23 hours 56 minutes. That's a sidereal day, and the 4 minutes a day is 1 degree. So that's exactly why the solar and the sidereal days are different. It's because of that 4-minute 1 degree offset. So the fact that your clock that is tuned, well, if you know all this, why do you present it as though it was an argument? Because it's not.
Because a 24-hour clock is a fixed mechanical device, and it's measuring sun time.
24 hours. The time it takes for the sun to get back to the same position.
Sidereal time is the difference, is because the stars are rotating around above us every day about 4 minutes faster than the sun. And that's why the sun seems to appear to rise in a different house of the zodiac once a month, until eventually after 12 of them, it comes back to the starting position. And that's how we have a New Year's.
That's absolutely untrue. The Earth rotates relative to the stars, but the sun has moved in the meantime. That's why a solar day is longer than a sidereal day. It's got nothing to do with the rate of rotation of the stars.
It's a fixed measurement of time. It's 24 hours, 360 degrees every single day, and my clock doesn't need to be adjusted because it's always going to be overhead at 12 midday.
Except that it isn't precisely overhead.
Don't you understand it?
What is the accuracy of your clock? What are the accuracies of your observations of the sun?
Exactly with my sundial.
Exactly with your sun. What is the accuracy of your sundial?
It's always going to be overhead.
What is the accuracy of your sundial?
If I set my clock, it's always overhead at midday.
What is the accuracy of your sundial? I'm asking you a question. You can either answer the question or say I'm not going to answer it. What is the accuracy? What is the accuracy of your sundial?
It never changes. I don't understand your question.
My question was, what is its accuracy?
I don't understand your question. Explain it.
Okay. So how precisely can you measure when solar noon occurs? 1 second? Are you accurate to within 1 second?
When the shadow hits in the middle of that Neumann,
Okay,
it wouldn't matter.
Yes, it does. It matters a lot. If you're not using, so you're using the same timekeeping techniques that were available 2,000 years ago, and you're saying, well, the more accurate techniques that we've developed in the meantime, they should be discarded, because I can tell using this 2,000-year-old instrument that it occurs exactly the same time. And then you've got a clock, and then you've got a 24-hour clock whose accuracy you similarly can't delineate. You're not making accurate observations of the position of the sun overhead. So you're just saying, you're eyeballing it and then saying that the people who aren't eyeballing it are wrong because they've got fancy instruments.
It wouldn't matter if they were eyeballing it or not, because it would change by 4 minutes per day to the point where after 3 months, it'd be midday at freaking sunset. And then another 3 months later, it'd be midday at midnight, according to my 24-hour clock. And then another 3 months later, it'd be midday at sunrise.
No, it wouldn't.
And then another 3 months, you'd be back where you started.
No, it wouldn't.
That's exactly how it would work.
Seriously, Ross.
It's an exact, precise measurement of time. 24 hours per day by the mechanical clock.
You need to be quiet now. Seriously, Ross. Seriously, Ross. You think that the greatest scientific minds of the past 400 years have failed to notice that 24-hour clocks keep pace with the sun? That's what you're saying.
Had batteries back then and had a mechanical 24-hour clock.
They did. They were pendulum driven.
They did.
Yes. Pendulum
pendulums.
driven.
There we go. Back to the greatest instrument of the soothsayer. And
okay, Ross, at this stage, look, you're just going to say no. You're just going to say no to any evidence that's presented to you. I presented you evidence that the length of day is not precisely, not precisely 24 hours. I presented evidence of mass attracting mass along multiple axes, and I presented evidence of gravitational time dilation, which would be completely inexplicable under your model. Why there's no explanation as to why that occurs or how that occurs. So at this stage, this backwards and forwards is completely futile. You're not accepting evidence. You're just asserting that stuff is wrong. Great. It's a 24-hour clock. What's its accuracy? When was the last time you tested its accuracy? When was the last time you tuned it to, say, a radio signal that astronomers use?
Do you think it's going to go out by 4 minutes every single day? That's what it would do.
Ross, your alleged syllogism here. You've presented your evidence. You've presented your evidence. The fact that the 24-hour clock matches up with the sun is by design. That is how we have designed the 24-hour day. So the fact that it still matches up after 6 months, that is how we designed our solar calendar. That's why it's called a solar calendar.
Tony, you're a fucking moron. You don't understand that if we were going around the sun and the Earth was spinning on its axis every single day, if the Earth was spinning every single day on its axis and we're going around the sun, then the clock would be wrong by 4 minutes every day.
No, it wouldn't, because 24 hours is the period that it takes. 24 hours is defined. We allow for that 1 degree offset in the 24-hour day. That's why day length is not 23 hours, 56 minutes.
We may want to go in.
It's a fixed amount of time.
Now let's go into questions. This is pointless. He thinks he's making a point, and he's just too stupid to understand that he's defeated himself.
Amount of time. It doesn't
We're going to jump into
it's
the Q&A.
fixed.
We have a number of questions here, folks. Thanks so much for your questions, folks. If you happen to have them, you can either submit it via the live chat as a standard question, tagging me at Modern Day Debate. Otherwise, super chats go to the top of the list. With that, thank you very much. This one first coming in from Pepe in a blue suit says, "Don't drop the soap. It won't fall. I'm proud of your boy, Yurahu." Is that meant to mean Ross? Did Ross drop the soap? This one from LJ says, "Why can't we isolate or measure or control gravity?"
We can. We control. We did the experiments that I showed, where we isolated it from electromagnetic effects and from atmospheric and density effects. We can control it by controlling the mass distribution. So we control that. We can't turn off mass any more than we can turn off electrostatics. But flat earthers are happy to accept that electrostatics is real while claiming that gravity is therefore false. We can't turn off fundamental forces like electrostatics or gravity. What we can do is control the distribution of masses or the distribution of charges and see whether the system responds in accord with our laws. That's what we do, and every time we check, the system does. So that's just a non sequitur question.
You got it. Thank you very much for
I
this
remember
question.
learning in high school. We just use our plastic ruler, tear up little bits of paper, rub the ruler across our shirt and hold it above it, and the paper would be attracted. So there's an electrostatic force, and it's anti-gravity.
I'm not saying that electrostatic forces don't exist. I'm saying that the evidence that the claim that electrostatic forces need to be turned off again and on again in order to be scientifically valid is a faulty syllogism. Similarly, the fact that you can apply a second force that is larger than gravity does not suggest that gravity has ceased to exist.
So this tiny little electrostatic force from a plastic ruler overcomes gravity. But gravity still exists. Gotcha.
This one coming in from, I do
Next
appreciate your
question.
question. IC Spin says, I'll ask for LJ. I think LJ was in chat, but we'll let Ross if you want to, or Tony, both of you, if you want to respond. How come helicopters stay in place?
Yeah, this is because they when they're on the ground, they start off with the tangential velocity of the Earth's rotation. When they take off, they keep that velocity. There's no force acting on them that takes that tangential velocity away. Therefore, they rotate at the same speed as the Earth's rotation. He keeps on asking this question. Well, I see Spin asked on his behalf, which I sort of appreciate.
The Earth's rotation is only the slowest speed you heliotards believe in, which is only 1 1/3 times the speed of sound at the equator. And yet you also believe that we're hurtling through space to orbit the sun 10 times faster than a railgun projectile. And yet all of this stuff just moves that speed to create the illusion that they're standing still. Gotcha.
It's not velocity. If everything's moving at the same velocity, the laws of physics don't change. It's only accelerations that will have a detectable effect on physical systems. And as I have explained several times, the rotational effects of Earth's rotation in a day are detectable. The effect on the rotational effects of Earth's motion around the sun is absolutely tiny. Anyway,
it's massive. It's 65 times faster than the actual rotation.
Rotation speeds are not measured in kilometers per hour or linear speeds, as you say. They are measured in radians per second.
I didn't say that.
And 2 pi divided by 3.15 by 10 to the 7 is a very small radial velocity, angular velocity.
1,600,000 miles per
Again,
day.
It's not measured in linear velocity. It's measured in angular velocity. 2 pi divided by 3.15 by 10 to the 7 is a small number.
Figures. Let's talk about this in factual numbers. 1,600,000 miles
is
per
not
day
a measure of angular velocity.
It's the orbital speed.
Even if it's the orbital speed, you divide that by, you square it and divide it by the distance, which is 1.5 by 10 to the 11.
Nothing, man. I'm talking about fucking reality. Stop it with your mathematical bullshit.
Okay, so you remember you talked about the centrifuge thing, the gravitron or whatever it is. That was designed by engineers. The engineers needed to know exactly how much force that machine was going to apply, and they used a formula to determine it. I know what that formula is, and your claim that it is purely theoretical is the ignorant prattling of somebody who's never had to achieve something in real life. You've never had to model centrifugal force.
Your fucking spinning space ball, you moron.
You've never had to model centrifugal force. You've never had to work out how big it is. Therefore, you've got no understanding of the various factors involved. So maybe, and a sane response to being ignorant would
come
be to
on,
shut
stop
up.
waffling. Next question.
Let's let Tony finish his sentence, though. Tony, do you have
I
anything to
did.
add?
No.
This one coming in from Earthly Skeptic says a clinostat, am I saying that right? Is a device carefully constructed to cancel the downward gravity vector and simulate zero gravity. Iron Horse, explain its working, explain how it works using density.
A planostat. I
Thank you.
don't understand. Like, everything works according to density and buoyancy. And so if something is light, it's obviously not heavy. That's why it's up there. And the heavy stuff gravitates down here. I mean, I'm happy to use the word gravitate, but it's only because it means weight. And that's why everything sits at the base if it's physical and the lights are up there. I don't know.
You got it. This one coming in from, do appreciate your question. Earthly Skeptic says, Iron Horse, predict the acceleration of a block placed on top of a frictionless slide inclined at 60 degrees horizontal, as per your understanding of gravity.
If it was frictionless, how could it be a slide? It'd have to have some amount of friction to make it slide. Otherwise, it just drops straight down until it meets the place of resistance here at the base of the universe. I don't understand.
Yeah.
Tony, are you agreed?
No, I find that was meaningless gibberish. A lack of friction does not imply a lack of reaction force. The object would move down the slide, and the acceleration it experiences would be g times the cos of 60 degrees, I think, which is a half g.
You got it. This one coming in from JSS Tiger says pressure is force divided by area. Density is mass force divided by volume. Come on, Iron Horse, you soy boy. I added the last part. But what do you think? Iron Horse, do you understand? Like, do you agree with them? Do you disagree with them?
I agree that the density of the medium is what's going to cause the resistance force. That's about it.
You got it. And then Sunflower says Iron Horse's ideas are cooler and more fun, so I'm siding with him. And why shouldn't I? Oh, science-obsessed liberals provide no hope. Oh my goodness. Tony will give you a chance to defend yourself against this swine, this digital swine. Go ahead, Tony.
Well, sort of, you're free to choose not to engage with demonstrable reality. That is your choice. And yes, science is often a lot more boring than Game of Thrones. For instance, Game of Thrones or Last of Us, they're really nice, but they aren't real. And so perhaps if you're making decisions about the real world, you might want to engage with the real world through science, as boring as it is.
The Last of Us
I've never
used to
even
be.
watched Game of Thrones. I'd like
Go
to.
ahead. Go ahead, Ross. I can't spoil it. Go ahead.
No, sorry, I was just saying, I've never watched Game of Thrones. I hear it might be interesting.
How dare you, Ross? That's one of my favorite shows. Winterfell and
Um,
all
can
the
you
great.
send me a link to where I can watch it from the start?
Oh yeah,
I
I'm
don't
just gonna
watch
send
anything
you
from
a
unless I
pirated
see from the start.
copy of it, Iron Horse. You have to go fuck. This one coming in.
Thanks, James.
Yeah.
Go to JB Hi-Fi. They'll sell you a complete series.
IC Spin says Ross being held to Earth. Ross being held to Earth is acceleration towards it.
No, it's not. It's this when you're at rest, there is no acceleration. So to me, that is completely faulty. That's the whole reason we can weigh something is because we're measuring the resistant force from the density of the ground. And you can prove that simply by measuring yourself on your tiled floors on the scale, then move your scale and put it on the carpet, and you'll weigh less. But you're still got exactly the same weight that you've always had. It's always the resistant force. That's the only force that exists, is resistance, and that comes from the density of the mass. So whatever medium you're in, like you can float in water, but you won't float if the pool was empty. You'll fall to the bottom. It's always the resistance force from the density of the medium.
Except that that doesn't explain gravitational effects at a distance, nor does it explain any of the experimental data I showed, nor does it explain gravitational time dilation. So apart from the fact that it doesn't explain any of the scientific observations that I presented earlier, great explanation, Ross.
But you need dark force and you need dark energy, dark matter.
For what?
So great explanation, Tony.
For what? What do I need dark force for?
To prove that gravity doesn't exist and doesn't attract everything towards everything.
No,
it doesn't prove
that. No, that's not what dark force.
You need 95% dark force than you do gravity.
Dark force isn't a thing, actually, mate.
Just to prove that gravity isn't even a force.
Dark force isn't a thing, mate.
So you don't need dark matter. You don't need
dark energy and dark matter are things, but you're using them in basically incoherent. You're making no sense. We don't need dark.
Okay.
We don't need dark matter to explain that gravity exists or doesn't exist. It's got nothing to do with.
So why doesn't the moon fall to the Earth?
The moon doesn't fall to the Earth because its tangential velocity is large enough that it keeps on missing the Earth.
Okay. Yeah. Thank you.
And there's nothing slowing it down because it's in space. And in fact, it's getting
What's accelerates it though to keep us coming back around us when we're moving past it?
Yes,
at 66,600 miles an hour.
It is accelerated. Yes, and gravity accelerates it. Well done.
This one coming in.
Gravity. Got to the gaps.
Listen to Ross, so self-satisfied. All right, this one coming in from Mutton Chopper says gravity strong enough to hold the moon in position, yet not enough to pull million-pound rain clouds to the ground. Same with the moon. It pulls on oceans and not anything else. LMAO. I think that's some sort of slang that the young people use.
Laughing my ass off is what
I think it means laugh my.
There's multiple fallacies in that. Again, just because there are buoyant effects, just because there are buoyancy effects that act upward, doesn't mean that gravity doesn't exist. You can have multiple accelerations applied to molecules like water vapor, and you can have millions of kilograms of water vapor in clouds, but they're spread out so that their density is such that the upward buoyant force keeps them aloft. There's no contradiction with gravity there at all. The claim that the moon only attracts water is similarly not true. Earth has what are called solar earth tides, where pretty much everything goes up and down by about 40 centimeters over a 12-hour period. You can detect this with GPS detectors. If you get it, also with GPS, you can detect the pressure loading effects due to atmospheric tides. So the claim that both claims there are false. We've investigated solid earth tides, we've investigated atmospheric tides, and we can demonstrate their magnitude and their characteristics. So thanks for playing, as the flat earthers say.
This one coming in from...
I feel so honored to be educated by a doctor.
Wow.
Sorry, James.
About time we get some gratitude out of you, Ross. This one coming in from... JSS Tiger says acceleration can be a scalar value, and so speed can relate to acceleration. Iron Horse gets a point. Wow.
I think if we're having a scientific discussion, I would suggest that acceleration refers to change in vectors, particularly when we're talking about orbital velocities. Because this is a common feature of there was another flat earther that I debated on here who claimed that the moon, the ISS and the moon aren't gaining in velocity, and therefore they can't be accelerated. They are being accelerated because their velocity is changing direction. So when we're talking about gravitational acceleration, direction is critical. And no, speed is not. So while colloquially, why am I struggling with that word? Colloquially, that's
because you're insane.
Yep, and like all of your assertions, it should be treated with
everything
all
you were
serious.
talking about here is absolute fucking insanity. Absolutely
Wow.
insane.
We'll move on
If
to the
the
next
Earth
one.
is going 10 times faster than a railgun projectile through a vacuum of space, and you think these things are hanging under us, you are fucking mental.
Wow.
One of the two of us has had our ability to logically process data formally assessed and accepted as of a certain standard, and it isn't you.
This one coming in from, do appreciate your question. Artful Da Jr. says, Iron Horse, describe what the sun is. Tony, listen to daddy. Okay, I guess Ross is daddy. Go ahead, Ross.
Look, if I had to explain the sun, that's going to be a little bit tricky because you have to understand the flat Earth model. Everything finds itself according to density and buoyancy. And so at the top layer of everything, above everything, we have, because everything gets colder and colder, we have a massive ocean of superfluid helium shielded by the layer of frozen hydrogen. So when this massive energy source comes through the hydrogen layer, it creates a massive plasma orb of light, much like when an arc welder puts his power source onto something and in contact with the Earth. So we've got this orb of plasma, and that's shielded by the helium. But when we're looking up at it, we're looking up through another shield, which is our atmosphere, and that's where we see our apparition of light. So the sun is never where we think it is. It's not where it appears to be, because it's going to be different for every person, always looking up at the same orb. But that's basically our sun.
Follow-up question. If as you get higher, you get closer to the sun, why does it get colder as you get higher?
Because the sun doesn't create heat. The heat actually comes from the Earth itself down in the neon layer, and that's why the clouds themselves sit upon the neon layer, because that's the condensation layer, and that's why it reflects that orange layer off the bottom of clouds. But the heat comes from the Earth and the light, just like a light bulb creates heat once it's lit up. It doesn't create heat. The sun does not create heat. The sun is actually cold
doesn't
fusion.
create heat.
No, it's absolutely cold fusion. But the light that the sun creates heat.
So why are days warmer than nights?
Because we've got daylight. When the atmosphere is ionizing with daylight and the neon layer is ionizing, creating light, as we see reflected in, say, ice and snow and the bottom of clouds, they all appear white. It's from the neon. But at the edges of neon, it appears orange. And that's why we see the reflected colors come off the clouds at twilight. The heat stops because the light stops. The light is what creates the heat, not the sun.
And
it's the light.
So does the sun create the light?
Yes, it's the power source.
So it supplies the light, but it doesn't get hot. So it's not like a light bulb.
No.
Okay.
No, it's like the electricity in your wires. The electricity in your wires doesn't create heat. The heat comes from the light bulb once you turn it on.
Yep. Great explanation, Ross.
Thank you.
This one coming in from, do appreciate your question, from JSS Tiger Strikes Again, says, Iron Horse, buoyancy, in all caps, is a result of gravity. The buoyant force is equal to the weight, in all caps, of the displaced medium. How do you like them
it's
apples?
all about the displacement of the medium. So you displace X amount of medium, whatever you're in. So say if you're in air and you're in a hot air balloon, then the density of that is less than the density of the surrounding air, so you will rise up. But if you're greater than the density of the medium surrounding you, you will sink. Yeah.
So buoyancy arises because of the pressure gradient in the medium, and the pressure gradient in the medium arises from the existence of gravity. So without gravity, you can't explain the pressure gradient in the medium, so you can't get a buoyancy force. The existence of a second force, a buoyant force, is in no way a contradiction to the fact that gravitational acceleration exists.
Thanks very much.
Well, what about
And
if you're at the bottom of the ocean? If you're at the
Yep.
bottom of the ocean, you're going to
And
have a far greater pressure simply because there's a greater volume of water above you. But if you
exactly.
release, say, an air bubble, it's going to rise up through that no matter what, because in a sense, it's the same thing as I said before about the pressure difference, whether it's low pressure going to high pressure or high pressure going to low pressure, they're both doing the same thing. They're always going to, that's how you find the buoyancy effect. So, it doesn't have anything to do with gravity. It's just
It
the amount of
does.
pressure from the volume of the matter or material above you.
When you calculate the pressure gradient in the medium that you're considering, that is a function of gravity. This is what I was getting at when I was talking about hydrostatically ordered fluids like the ocean and like the atmosphere. Pressure at every point is caused by the weight of the material above you. So yeah, you need gravity for that to have
No,
weight.
you can
Yes, you
still
do.
call that the volume of stuff. The volume of stuff will have weight, but it doesn't need gravity. It doesn't need a pulley sucky force from the middle of a spinning space ball. It's just the volume of stuff above us on a stationary plane
So
array.
what is it that calls, why do things fall down? So I've got an object
Because they're
here.
more dense than
Why
the
doesn't it go
medium
to
they're
the
in.
path of least resistance?
Because they're
The air
more
is
dense, the less
okay, but
dense
it's
medium will not give it buoyancy.
yes, it will. We can demonstrate that. We
No,
can
it
measure
will
it.
not.
Yes, it will.
No,
We can measure
it's
that.
the
We can measure the
relative
weight of.
density of the object to
We
the
can
medium
measure.
that will give it
Well,
buoyancy.
you're talking in opposition to science. When we measure the mass, well, the weight of an object in a vacuum, it is greater than the mass in when you measure it in an atmosphere, because the atmosphere applies a buoyant force. You don't know what you're talking about.
How are you weighing something?
Using standard scales.
So you need a resistant force to measure the weight of
That's
something.
got nothing to do with what I just said. What
It's
I
got
just
everything
said
to do
is
with
that an
it.
object,
You
an
can't
object,
measure it
an
unless
object of the
you've got a
same
resistant
mass,
force.
an object of the same mass weighs more in a vacuum chamber than it does when you weigh it in an atmosphere. That's because of the
air
buoyant force.
offers a resistant force.
That's because
You've
of the
removed the
buoyant
resistant
force.
force in a vacuum.
That's because of the buoyant force of the atmosphere acting on the object. And we can measure the buoyant force, and we can show that it's the buoyant force. This is to say that buoyancy and gravity are different things. They act in opposite senses. Anyway,
it all comes from the resistance of the density of the material or matter that they're in. So the
he
air
said
has
with the
some amount of
facile
resistance.
assurance of the completely
A
ignorant.
vacuum has zero resistance.
A vacuum has zero buoyancy, provides zero buoyancy. It's not
exactly,
resistance.
because it's zero resistance.
It provides
So
zero
simple.
buoyancy, but there is still a
So
buoyant
simple.
effect on the object, which you denied. You said that there isn't a buoyant effect on an object that is denser. You said that if this thing is heavier than the air, you said that if it is heavier than the air, there is no buoyant effect. We have now established that there is a buoyant effect, and that therefore what you said was just bullshit you were making up because you don't understand the topic.
take that, Ross. Okay, here we go with the next one. This one is from
Got me.
Specs. It says, Ross, can I get a table of resistance factors of each material? What does that mean?
It means that he wants to
Yeah,
know how to calculate acceleration in different gases and different liquids.
I
He
think
wants
this
to.
is for me, Tony.
Yes, I am explaining the question because you have demonstrated an inability to understand English.
What do
Oh,
you think, Ross? Let her rip.
what he actually means is, yes, we can demonstrate this in something that we call a density tower. So it shows much more clearly in different liquids. So when you've got different liquids of different density, they will separate themselves up to different layers according to the density. Yeah, it's easy
He
to
didn't
demonstrate
ask you
there
to
than in
demonstrate it.
solids
He asked
than
if
it
you
is
could
in gases.
tabulate it.
Can I tabulate it? No, probably not. I'll just observe it.
This one coming in from, do appreciate
Sorry.
your question. This one coming in from my boy Isa. Isa, I got to give you street cred. Appreciate your loyalty. I don't deserve you, bro. Iron Horse / Ross says, you mentioned Newton's first law of motion. What do you think of his law of universal gravitation? Great job to both PhD Tony and Ross. All right, Ross, what do you think? You mentioned Newton's first law of motion. What do you think of his law of universal gravitation?
I'm not actually sure about his law of gravitation. Like, does that mean mass attracts mass? Because
Yes.
if that's what it means, then
Yes.
I think it's just rubbish. The
Okay,
actual
but
law of the actual law says that everything is actually diamagnetic, which means it repels against everything itself. So basically, things will find its place according to relative density, but they never actually fully touch because of the diamagnetic force says that molecules do not actually touch. And that's what keeps us from walking through walls and molding into one another.
This one
okay,
coming in.
here's a magnet. I drop it, it falls. I turn it the other way up so that the magnetic face is on the top.
Does it go
Still
up?
falls down. So why, if it's magnetic,
Oh,
when
disappointed.
I reverse the orientation of the magnet, does it still fall downwards?
That's not diamagnetism. It's still
No,
magnetism.
diamagnetism means repelled by
Yeah.
magnetic. But if you reverse the
No, it doesn't mean repelled by magnetism. It's a completely different thing. It's another field altogether.
no, you're wrong.
You need to watch What the Bleep Do We Know? Diamagnetism means that nothing actually touches anything.
Diamagnetism is the
Because
property of
if we
materials that are
didn't have
repelled
that,
by a magnetic
then we'd
field.
meld into one another. We would meld into, we could walk through walls, we could do all this sort of shit. Diamagnetism means we are repelled from other things.
No, diamagnetism.
And we don't stick to them. That would be magnetism.
You don't. So look up diamagnetism. Diamagnetism is the.
I know what it is.
No, you don't. You just misrepresented it. So you think you know what it is, but you just lied about it.
That's why we have tides in the first place, is diamagnetism.
Yes, you claimed that earlier and you were unable to demonstrate that. Diamagnetism is a property of objects that are repelled by magnetic fields.
Repelled.
Right? So if everything is diamagnetic, shouldn't it repel this magnet upwards?
No, the magnetic force
shouldn't
is
it be repelled? Shouldn't it be repelled from the moon? Right.
That's why the moon is up there.
The moon is repelling magnetic fields. So shouldn't this be repelled from the moon? Why isn't it?
The moon is repelled from us. That's why it's up there and it stays the same distance from us all the time.
Why isn't this object, this magnet, repelled from the moon? If the moon is diamagnetic and forces magnetic fields away, why is this thing not repelled directly away from the moon?
Well, does it go to the moon?
No, it goes down.
That's because the moon is up. Good. Well done.
The moon isn't up. The moon is off to the side.
Everything is always up above us and it's parallel to the ground.
No, it's not.
Rotating
the moon is
above
never overhead. The moon is never directly overhead. The moon is never directly overhead in the when you're more than 5 degrees away from the 5 degrees
Oh,
away
it
from the
doesn't
equator.
appear that way. That's called perspective, Tony. Are you new to perspective? I can teach you about perspective.
You couldn't teach me anything.
Wow.
Do you look down
This
a hallway and
we
think that the lights further down low are actually lower than the ones right above your head? That's perspective. They're the same height.
will
The
jump into this.
moon, so the fact that the moon is oftentimes invisible because of its remoteness is not, it does not mean that it's off to the side. That's
What's that?
perspective, is
No,
it?
we
So
always
it's
see everything
still
for
it's still
approximately 12
directly
hours
over
a
us.
day.
It's still forcing this thing directly down, even though it's over there. That's your claim.
The moon revolves around us 24 hours, 50 minutes per day in accordance with the tides that we witness.
Yes, we agree. We are in agreement that the moon causes the tides. What we are disagreeing about is whether or not the moon is repelling this magnetic object.
This
No,
one.
it has a diamagnetic force against the saltwater oceans only. That's it.
Yes, but this is a magnetic field. If diamagnetic means that it repels magnetic fields, so it should repel this object.
It would.
The moon is more massive, I assume, or has a stronger field. Therefore, it should be able to repel this object. This object weighs less than
subtle when the moon is overhead. You
this.
wouldn't even notice.
Yeah, except that the moon isn't directly overhead at any point for us, Ross. Neither of us are within 5 degrees of the equator.
It's approximately once per day. I've seen it overhead occasionally because it goes in an elliptical
No, you
path.
haven't, Ross.
That's why it takes the extra 50 minutes every day.
No, you haven't seen it directly overhead, Ross. It stays within 5 degrees of the equator.
Must move to the next question. This is from Rev MSJ. By the way, thank you so much. Rev MSJ made a donation to the GoFundMe, which, folks, we are using a GoFundMe to fundraise for our lenses for our upcoming in-person debates. So thanks so much, Seth. Seriously, really appreciate that. For your thanks for your generous donation. That means more than you know. And their question was, in particular comment, they said, please ask Iron Horse for me to wear his helmet, please. I think they're saying, Iron Horse, will you wear your helmet? They're saying, Ross, will you put the helmet on? And they say he cannot afford another bump on his dumb head. Oh, come on. No. He's got a nice head.
Man.
Okay.
I prefer to leave it in my pants, man. Like until the whistle misses.
No, where's the stream going? What was that? Okay, did you just say pants? This one from, don't answer. This one from, oh, we have a huge, tremendous, but yeah, thank you so much for that support of the GoFundMe. And this one, that's linked to the top of the description, folks, and I'll pin that in the top of the chat. If you put in a donation of any amount, no matter what the amount, we will read as long of a question as you have. So if you want to do a page or something. Issa Kavir says, so we got his. Thanks for that. Artful Da Jr. says, Tony, the sun comment was for a laugh. IQ drop. Let me look up the sun. What was this about the sun earlier? They said horse, describe what the sun is. And then they said, Tony, listen to daddy.
Yeah, I know. Yeah, I knew it was, I knew he was, he was poking fun at me. But it did prompt Ross to just vomit nonsense into the stream, which I guess assists everybody in making up their minds as to who's more credible.
I made up the daddy part, though. He didn't.
I didn't even come close to explaining where the sun was either. I didn't even come close. But you need an introduction to where things are. Like sometimes the sun is in the clouds. Sometimes the sun is actually in the water. You can actually get sunburnt in a boat with the shade over you from the sun reflecting off the water. So that must be the sun if it's still going to sunburn you. The sun is everywhere and nowhere.
Interesting. And this one coming in, such a poet, Ross. All right, retired says, if you shoot something up into the air, why does it slow down the less resistance it has, but speeds up the more resistance it gets while coming down?
Because it itself has matter, and the atmosphere, it doesn't really thin out that much. It's going to give it enough resistance, and the object of mass is still way more powerful than the resistant force of the mass that isn't there to resist it. And so it will accelerate because of the lack of resistance.
Wow. This one coming in from Rev MSJ says, I wrote it twice. Don't read it twice unless you think you forgot. They want you to put your helmet on, Ross. But this one coming in from, let's see, I think that might actually be to the end of the list. It's getting dark over here, folks. As you can tell, I'm in Las Vegas and the sun is setting and it is going. I'm gonna get a light soon because this does look ghoulish on my
Sin
side.
City.
What's
I
that?
will
You had a
just
little joke there,
quickly
Ross?
point out something.
Yeah.
Oh, I just
So
said Sin City.
we can actually track the trajectory of the sun using neutron detectors. So we can detect the neutrinos, emitted by the sun as the sun goes under the planet. The claim that the sun always stays above us is easily falsified with scientific evidence. It's just the flat earthers always ignore it.
Wouldn't it work the
Ross.
same way even if it was above us? Just went far
Nope.
enough away.
No.
No? Okay. Okay.
2 seconds,
I
folks.
accept your beliefs. Like your faith has made you.
Is this smack talk, Ross? I'm gonna turn on the light. Thanks. ZH Kane says for James, can you say wow for us? Thank you for your super chat. That means more than you know. And also, yeah, we'll give one last call for questions. And otherwise, what I'm going to do is turn on the light. And then when I get back, if there aren't any more questions, we'll wrap up. So thanks for your questions so far, folks. We'll see if you have any last ones. I'm going to turn on the light so I'm no longer sitting in the dark. 2 seconds. Ross, can you promise not to do anything inappropriate as I step away?
I promise I will do nothing inappropriate. James steps away. I'd still love to see Tony actually present evidence for actual gravity, but you need to have
You didn't
beliefs.
pay any attention.
You need to have beliefs in order to believe you live on a spinning space ball. Whereas when you understand we live on a stationary planar Earth at the bottom of the universe, everything falls into place and you don't need to have any of these crazy ideas like an attraction of pulling force due to bigotry. It's just resistance. It's the only thing that stops us from falling.
So what causes gravitational time dilation?
Yeah, Ross.
I don't understand gravitational time dilation.
Okay, so you don't understand it, therefore it doesn't exist. Is that what you're saying?
Yeah, I just think you're making something up to try and affirm the consequences, or what do we call it? You've made up a belief, and so you'd like to what confirm it some way. Whereas, everything is as it is. We're all sitting here on the stationary planar Earth at the base of the universe. We're all physical beings. We've got an atmosphere rests upon us, and that's what we're breathing. And if we go too high, we run out of oxygen. We're not hurtling through space. The whole idea is nonsense. You can call it gravity if you like, because that just means weight. So everything falls down because of its weight. But it's just displacing a different matter until it comes to a place of resistance. So resistance is the force, not attraction of mass.
Then how does gravimetric mineral exploration work?
Because of the change of the density of the medium that they're detecting.
That doesn't explain anything. We keep the density of the medium constant inside our gravimeters. So it's not changing, nor is the mass of the proof mass. So what is causing the change?
But what are you detecting again?
Gravimeter? Pardon?
What are you detecting?
We're detecting.
What are you detecting?
We're detecting. Well, it depends on the style of gravimeter. We're detecting the acceleration that is applied to the proof mass, whatever form the proof mass takes.
This one coming in from, do appreciate
So
your
you're
question.
detecting oil has a different density on the ground. Gotcha.
Well, okay, this one from Dad is bored. Thanks for your super chat. Said, don't forget, matters now. for the after show. Juicy. Now we are going to wrap up. Want to say, folks, we do appreciate you hanging out here. We will be oh my gosh, you guys, seriously, it is like in the next couple weeks, there are going to be some massive juggernaut debates. Starting with, folks, if you didn't know, if you somehow have been living in a cave on Mars with your fingers in your ears and you hadn't seen at the bottom right of your screen Andrew Wilson versus Apostate Prophet on whether or not Christians should support Zionism. That's going to be controversial. And also, not only that, that's going to be epic, believe me, but also, there we go, 3, 2, 1. As you can see at the bottom right of your screen as well, Destiny versus Andrew Wilson. You can get tickets for both of these links below. I don't know what you're waiting for, folks. Now is the time to grab tickets as time is running out. So that first debate I mentioned will be this Monday. Seriously, you guys can't wait. There are free, if I remember right, there's a free ticket option for each. I think I think there's a free ticket option for Uncensored America. There's a $10 option for the second. But I mean, yeah, $10, you guys. The industry standard for debates like this level is like $20 to watch it live. So 10 is a great deal, especially for that debate. That's a big one. But I want to say a huge thank you to our guests. Seriously, they are the lifeblood of the channel. Ross and Tony, PhD Tony, it has been a true pleasure to have you guys. Thanks for joining us.
Thank you.
I'm pretty sure the check's in the mail, isn't it?
That's right. And Max V says, come to Matters Now, Iron Horse. Wow, they're summoning you. They want you there, Iron Horse. They want a piece of you.
They're going to unban me, are they?
Oh my goodness. Wow. This
I get banned all the time.
Oh, I believe it. All right. But yes, thank you, folks. We appreciate you guys. I'll be back in just a moment with a quick post-credit scene. I'm going to let our guests out, so stick around.
Yeah. I'm not dying. Get out of here.
Amazing, my dear friends. We are excited to be here. I'm going to tell you about all of the interesting stuff coming up. And now my lighting makes me look pink. Let me see if I can fix this. Why does it look pink? So it's actually the lighting. That's why I look so bad right now. Oh wait, no. Let me fix this. It is the lighting, but okay, that's embarrassing. I was muted the whole time. Thank you for your feedback. Yeah, that's right. You guys don't know sign language. I was still talking to you, but I was just using my hands. But yeah, thank you guys for your support. Human Girl says, wow. That's right. Human Girl, one of my favorite cats, hanging out here a long time. And Batman Inc., one of my favorite cats, also been hanging out here a long time. And Rev MSJ, one of my favorite cats. Thank you for your generous donation to the crowd fund. Seriously. So we are excited about this. We are planning, we want to use the lenses at this Monday's debate. I'm going to throw that GoFundMe into the top of the live chat right now, folks. We really do appreciate your support. For these lenses, you might be thinking, like, I don't understand, James. Why would you want to buy these lenses? So sometimes people are like, It seems like a dumbass decision. Why would you do a dumbass decision? It's not a dumbass decision, and here's why. One, because one time one person was like, he's, all those like sassy boys in the live chat, and they're like, "Ugh," it's like, this, they're just like, "Ugh." So he's like, "Well, why don't you like just buy one lens and test it and see if you like it?" And I was like, "Well, we already did. I just told you, like, we rented these before, and they are amazing." And so we're like, "Hey, uh, we've already used these for DebateCon 5. If you saw DebateCon 5, that obviously was like a major step up in our production. I mean, DebateCon 4, you still had me running around in the back doing all the tech stuff. It was a monstrosity. I don't know. I can't believe I had some cojones on me that I even thought I could do that stuff. It was more just ignorance than courage, I assure you. It was just that I didn't understand how like hard it was to do. But I gotta tell you, Jeff and Sean did an amazing job at DebateCon 5. And part of that is, yeah, because the lenses are amazing. Uh, and so we're like, "Hey," and someone was like, "Well, why don't you just rent them?" And it's like, well, the amount that we're going to use them, it just makes way more sense to buy them because no joke, it's like, if I remember right, it's $150 to rent the lens for like one-time use. But we're like, well, okay, well, if we're going to use it 10 times, that would like basically pay for the lens, like as if we were going to buy it 1.5 times buying it. In other words, if we rent them that many times, we're eventually just going to spend so much on rentals that we'll have spent more by renting compared to if we just bought the lens for ourselves and then just use it a ton, which we are going to do. So that's why is it's very financially clever. We're like, hey, we know we're going to use them a ton. I am basically going full time with Modern Day Debate. I'm no longer teaching. So a month from now, I'm spreading my wings. I'm going for it. I'm doing the life that I got to do, which is what I enjoy. And so I'm not going to be teaching anymore. I'm going to be moving on and yeah, modern day debate full time. We're going to do a lot more in-person debates. We are going to take a lot more big risks with big name speakers. Like seriously, there are going to be some huge debates this year where you're not even going to believe it. You're going to be like, "Oh, like really? Serious? Like, holy smokes, how?" It's going to happen. We're finally going to throw our weight around. We're going to finally point to the far left field, signifying that the home run is about to happen. It's going to be a grand slam. We are very excited. I'm telling you, I've made new connections, not just in terms of Sean and Jeff with the tech, although that helps a ton, but in terms of people who are they're like, hey, let's take this to the next level. People have got a lot of event experience and they're like, here are different ways you can do this. Basically, kind of like a mentor. And I checked this guy, he's like fully legit and he's hosted like massive events. And I'm also kind of like, I was like in disbelief because I was like, really? Like, because he reached out to me. He's like, hey, I love modern day debate. And I was like, thanks so much. It's all because of the team. Like, thank you guys for all of your support. And thanks to all the debaters, they've made this channel awesome. And he's like, hey, but I love it. And I'm kind of thinking about those deep questions of life. And I would be pumped to collaborate with you. And I was like, bro, like, let's do it. We're going to like take some big risks. And I'm very excited though. They're calculated risks though. So it's not like willy nilly. It's going to be effectively planned and executed. Seriously, I'm pumped though, you guys. Thank you for all your support. Thank you for being a subscriber. If you're in the live chat right now, I know that you're a subscriber, and I want to say thank you, Dennis Van de Sluis, as well as Tom Tebow and Flat Plain, Oregon. Human Girl, thanks for being a subscriber for what, like 5 or 6 years? Probably about 5 years. Action packed. Fallout 4 Mods says DebateCon is incredible. Thank you for your support. We are excited that it just keeps getting better, and it's going to be this fall in Nashville, Tennessee. So it's going to be epic. As well as thanks Shovelhead 215, as well as not a scope, a ballistic calculator. Kevin Howe, thanks for your support. And then Mutton Chopper, thanks for being a channel member. And Rev MSJ, thanks for being a supporter. Bro Grow, thanks for coming by. Marilyn, thanks for your support and being a subscriber. I'm still convinced that Marilyn is a bot, but no hard feelings. if you're a bot. We're okay with bots here too, as long as the bot hits like. We're at 178 likes. You guys, I didn't want to say this because I didn't want to embarrass him, but Norek in the live chat, thanks for your huge words of support there. Norek said he would give free feet pics if we get to 200 likes. So please support Modern Day Debate. Get your feet pics. It's not too late. If you want some tremendous feet pics, they'll hit your inbox, your little email inbox very soon. We don't delay with the feet pics. We get them out fast. But yeah, I'm pumped. We are growing our Facebook, which is exciting because that's just a great way for us to be in touch with people and basically say, hey, we are hosting this huge event and it's going to be amazing. But yeah, I'm really excited. So, yeah, I had mentioned this Monday, Andrew Wilson versus Apostate Prophet. I will be there. I'm very honored to have been invited to be the moderator. So that's put on by Uncensored America. It will be live stream at Modern Day Debate. Uh, if you're nearby though, go get a ticket. I mean, that one is you. There's a free ticket option. What are you waiting for? How could it be better than that? So, got to tell you, we're really excited. Come out, join us, have fun, meet me, say hello. Like I like people. I'm a very extroverted person, and so I'd love to get to meet you. And not only that, but so that's this Monday. Then Destiny versus Andrew Wilson is on May 6th. I've been invited to, so that one is instead of Uncensored America, it's been being put on by Atheists for Liberty, who's graciously invited me to moderate that. So which I'm super flattered. Like that really means a lot. And yeah, Norek says I have my OnlyFans link ready whenever we hit the like goal. Come on, really? We only got like 2 likes from that. Norek, he just uploaded all these feet pics to his OnlyFans. We are at 179. Sommer, good to see you, bro. Says Yo James, excited for the events coming up. Me too. That means more than you know. And let's see. And Fanlin 101 says I can't hit like again. I appreciate that. You're right. If you already hit it, don't hit it again. Let's see. Iron Horse, thanks for your kind words. I appreciate that. Mr. Pharaohbot says, I am the bot. Thank you for your support. Means more than you know. And let's see here. Lucy, Lucky Haskins, thank you for your being a subscriber. Thanks for your kind words. Josh C says, congrats. I look forward to seeing this space grow. Yeah, we're excited. Like I've been for years, I've always been really conservative with modern day debate. So, um, like we've had some like popular people for sure, but I've always been like, it's always had to be like carefully, where like it's been an honor to have like Bart Ehrman and Lawrence Krauss and other like I think both those are New York Times bestsellers. And then, we've had plenty of other massive debaters, but now we're getting ready. I'll tell you that just to give you an idea of like the level that I'm like looking at. We're looking at like the level of people like Sam Harris, like big time names that just have the brand prestige that it's going to be, frankly, it's going to be a little bit risky, but we're confident it's going to pay off. So the law says, will Richard Courier come on again? Yeah, we do plan on having Dr. Courier on again. He's a pleasant fellow to interact with. But yeah. Thank you guys for being here. Kyler, thanks for your support. Alex, thanks so much for being here. And says, I didn't catch the debate tonight. How was it? Well, Marilyn says that Iron Horse won. Or, I mean, during the debate, Iron Horse started insisting that everyone call him Daddy. I don't know if that's going to fly with everybody. I know that, let's see, Sommer even told me, I talked to the Sommer on the phone one time, and that's not a joke. We actually have a good friendship. Like, he's a pal, and Sommer told me he's like I've wanted to call Iron Horse Daddy for years, and I was like that's weird. Why? Norek says I made that up. Marilyn says he is Daddy with a capital D. Dear. Oh man, okay. Just don't get Iron Horse all excited and he's gonna don't put a quarter in Ross. He's gonna be all excited and dancing and all cocky about being called daddy. Let's see. Norek says, does Vosh still do debates? Vosh is kind of unofficially retired, so uh ah, yeah, I am like I sometimes touch the banner behind me and don't worry, it's very secure. It is fun bouncing off the background. And yeah, Vosh, all the emails that I get back from him, he's kind of like, I don't know. I'm kind of taking time away from debating. And it got to the point where he kept saying that so much, I said, hey, how about like I'll stop asking you so often and you just let me know if you're ever gonna come back to debating. So yeah. Uh Jared A says, Iron Horse, do you mean Hot Tub King? That's right. I think Iron Horse is the only person that's ever been nude on Modern Day Debate. So, Sideshow Nav, good to see you. Thank you for your kind words. Good to see you, Bob. I hope you're doing well. Bob, I feel like I was actually during this actual debate, I was gonna check because I was like, did I respond to Bob? I was at the gym, I think, and I was about to respond and I got distracted. Let me just check right now because I'm so made it home. I'm so glad. Time to fire up the grill and make some dogs. That's so great. Seriously, Sideshow Nav, that is encouraging news. This reminds me of the good old days. We got Sideshow Nav here, and we have Human Girl here. We have a lot of you guys are longtime viewers. This is a good, it's very nostalgic. It gives me warm feelings. So back when I used to stream from my office at Colorado State, and I had yeah, this like nasty old big green screen that has like oh, sometimes my advisor would come in my office. She was like the nicest lady. She still is the nicest lady. But she'd like see this like weird stuff that like it looked like basically like a laundry rack, but I would just hang the green screen over it and they never asked, they never said like James, your office looks, this isn't your home. You should take that home. They never did that to me, which is really cool. Because they knew like my advisor definitely knew what I was doing and she was very kind and flexible. And let's see. Kokomo, thanks for your kind words. Says James, you and Modern Day Debate are awesome. That means more than you know. Modern Day Debate, we have so many supporters too, like for the events and stuff, like Brian and Chris and Bob and Sean and Jeff are kind of like new members of the Debate Con team. And so, yeah, we are like super blessed. And Summer, you said you'll be hearing from my lawyers for the slander, James. So I just called JF Papier when we talked. Such a nasty guy. He's calling everybody Papa. He's cheating on you, Ross. He just calls everybody daddy. And let's see, where is Summer's message? I was like reading one of yours. Still have super fringe internet people on. We haven't had JF on in a while. I know that he's one of your homies you like to listen to. I'm actually getting kind of hungry, which is like yeah. I love lately, I have to be real with you. Summer says, would you ever do an event back in Colorado? We might do one in Denver. That's like a real possibility, but I can't, probably wouldn't be able to do one in Fort Collins, but Denver's a real possibility, which if I remember right, you're in Denver, right? But yeah. Um, I've been on this kick lately of eating eggs and mayo. I put the mayo on top. I just smear it on the top and it's so good. It's so good. It's almost like sweet. It's funny that like mayo is like pretty much just egg, right? Isn't that what it is? And it's so, so good. But why does it taste so different? It has that kind of like sour, I don't know what the taste, how do you explain? What does mayo taste like? It's not quite sweet. It's not quite salty. It's so good. Tyler says, do an event on the moon, please. Should be pretty doable. That's a possibility. Although I got to tell you, these are like, eh, I'd say gravity is probably like the least popular topic. So this one is probably, we'll see how it goes in the old algorithm. But anyway, I'm going to get out of here in a minute, but I do want to say thank you for your support. Again, that GoFundMe is linked at the top of the live chat. We appreciate it more than you know. If you want to support Modern Day Debate as we are like launching, we're kind of getting ready for takeoff. The rocket is firing up the engines. It's going to be amazing. Thank you guys for your support. Love you guys. If you haven't, that's the other thing too, is if you didn't know, ooh, I'll show you with our cool emotes, as the kids say. You can see we have the amazing emote, or if you'd like to call your friends in chat a soy boy, you certainly can. You can say, there's Marilyn, because Marilyn, I suspect you're not a soy girl, but you're a soy boy, because I really do. There's like this real phenomenon on Twitter where like many of like the like alleged women's accounts are just dudes pretending to be women. And no offense, Marilyn, but but it's so true. And it's nasty guys, Sideshow Nav just has all these sock accounts, all these like pretty ladies that he's like, like, hey, yeah. He doesn't really. Sideshow Nav is a class act. And yeah, I'm pumped to see you again, Bob, aka Sideshow Nav. Um, or how do I say? Let's see. Iron Horse says no link from MaxiPad. What is wrong with you? Okay, so but yeah, if you say Marilyn is and then here's the emoji. You say soy boy is Iron Horse is going to jail. And the funny thing too is he's like, oh yeah, like remember when he was in the hot tub and he like exposed himself to the world and like, even yeah, I remember Bob telling me about it. He's like, no, no, it wasn't just like his butt crack. It was like everything. Ross just stood up. He was in the hot, yeah, which is weird. It's the only person that ever streamed a debate in a hot tub. And then all of a sudden, and we thought, of course, that he would like have a swimsuit on because like this is what normal people do. Then he just stood up, and it was like, okay, no, wrong, everything bad, traumatized, trauma, and yeah, Bob told me. I think, but I can't remember. Was I there for that stream? Because I feel like I. Oh no, I think I was. I think I hosted that stream, but I was like looking away for a moment. Like I like was looking. I was like picking up a water bottle or something, and then Human Girl says the bubbles just disappeared all of a sudden. Okay. She replayed it over and over. Some people are sick. Uh, and but yeah. Thank you guys. You guys are uh-oh. Kyler says Marilyn's real name is Rick. Oh no, Marilyn Sade. I mean, so are you Rick? And it's always like the middle-aged dudes, like it'll be like, 45. It'll be like, it looks like 28-year-old Marilyn, but then you find out it's like the old joke, Bob, if you remember it. It's actually 65-year-old Earl, the postal worker. It's nasty guys. They just want to know what it's like. I don't know. They say, Marilyn says, Iron Horse, they don't appreciate you. Yes, we do. Like we called him Daddy earlier. What greater honor is that? But yeah, so you remember, since we're here, and then I've got to go because we've been sitting too long, but I just enjoy going down memory lane. Um, remember when I was talking to my boy Steve? So Steve McRae was doing a stream the other day, and I always stop in and say hi to Steve because Steve's like a longtime supporter. He was like so gracious. I owe Steve. I feel like modern day debate, it got a huge burst of like energy and growth when the non sequitur show basically like folded. And Steve like was so kind to basically say like, "Hey, go everybody subscribe at Modern Day Debate. That's like the new non sequitur show." It was really kind of him. And so when he was streaming, I can't remember what he said, but I brought up Kyle. If you remember that story, let's see. Hmm. The good thing is Steve is healed. That was an awkward time back then. Oh my gosh, talk about drama, like soap opera stuff. Because Kyle, if you didn't know the story, Kyle and Steve were co-hosting the Non Sequitur show. Steve was like doing the booking, which I think is the most important thing. Kyle had a knack for marketing, though. He was good at marketing, and he was good at aesthetics, like the thumbnails. But long story short, yeah, like Steve got like booted out, and then he didn't even have access to the channel anymore. It was terrible, but it was like soap opera level stuff. Um, Marilyn says, never telling you where I'm at again, Kyler. I knew it! Marilyn, you are Kyle, aren't you? Man, you people are sick. Why would a grown man do that? Uh, no offense. I could get it if you just like once did it. Like you're just kind of curious, like what's it like? But but to do it all, just to do it constantly, like what kind of do you get your rocks off? Is it some sort of fetish thing? Uh, Matt Dubinsky says, I just realized James kind of looks like Ricky at a law. That's like a huge insult. That guy's like, isn't he? No offense, but I don't want to say it. Uh, I don't remember him being like particularly, oh, come on. I just looked up his picture. Don't say that. We don't look the same at all. We just have a narrow face. Uh, I've heard one or two recently. Someone said I look like what is his name? WWE wrestler Hendry? Was that it? I know it'll show in my shorts. Uh, what are they called? Shorts, suggestions, recommendations on YouTube. Because every time, yeah, and I watched one short of him because someone said I look like this guy. What is it? Like Kyle Hendry? Let me look this up. Kyle Hendry. Kyle Hendricks? Hendricks. WWE? Let me look up. Oh, there's shorts. Okay, I'm sure the YouTube will give me a short with him. Nope, this is unboxing a PlayStation. This is The Undertaker and Mark Henry, a turtle eating a crab. Where's this? Come on. Um, Walter White. Okay, now it's just gone. Let me look this up. My friend Jeff sent me a text. I've got to redeem myself since you said I look like Reki at a law. Jeez. Give me a chance. Okay, you guys can tell me. I actually don't think I look like this guy that much, this pro wrestler. I see it like a little bit. Let me look up. My boy Jeff sent me this. Dyad. Okay, so Joe Hendry. So I'm flattered. Joe Hendry. I just put it in chat. If you want to look up his name, Joe Hendry, like Henry, but with a D in there. Don't make that into something sick. Basically, I don't know. I think I look a little bit like him, but I don't want to. I'm not fishing for compliments here, but I don't think I don't have as square of a jaw as him. His is like, but yeah. Let's see. Marilyn says, James, you're gonna shake in your boots. Is that because instead of Marilyn, you're like 6'3" Kyle, who's 270 pounds or something? Because usually I don't shake when I'm in front of a woman. So I don't shake in front of a man though either. I'm not afraid of anybody. And let's see. Marilyn, seriously, it's so uh Human Girl says egotistical much. What? I didn't say it looked like what is it his name? Henry. I can't remember what was his first name? Joe Henry. I didn't say that I look like him. It's that what's the word I'm looking for? Jeff. Destiny Stream guy sent it. So yeah, take that. Stick that in your pipe and smoke it, Human Girl. It wasn't even me that said it. It was uh Jeff. He's a gay guy. Tyree L says, "Who's James? Just asking you, Marilyn. Thanks in advance. He. What does that mean? Who's James? I don't understand. 1776 says, James, I know you're hot. I don't know what that means either. Human Girls is not you, James. Oh, Joe Henry is, yeah, but like pro wrestlers, they all have to be like egotistical. It's just like a cool big character thing. Like every persona is like kind of egotistical. Come on, Sarah, like get with it. I mean, Barbara. Let's see. Tyree L says, I thought it's apostle, James. No, I don't know what that means either. But yeah, yeah. So thank you guys for your support. I'm pumped about the future. I just love hanging out here with you guys and just shooting the shit after the stream gets done. It's really fun. Uh, talking about all sorts of cool things. Let me just really quick check the price. I know that I'm not telling you guys to go buy it, and you guys are gonna just hate me saying this. Well, never mind. Thanks for your kind words. Native Wildman, thanks for being here. Thanks for being a channel member. And Jared A, thanks for being a channel member and thanks for being here. Says James, the guy with the subway tattoo. It is true. Definitely have a tremendous, I love this big, beautiful tattoo on my back. And let's see, 1776 says Hawk is a Titan. Oh, why thank you. I don't know who they are. But yeah, yeah. You guys make this fun. I am gonna eat eggs with mayo tonight, and I'm gonna eat plenty of them. And yeah, so this weird thing, I don't know if anybody else has it too. Really quick. I'm actually for real. If I eat during the day, I get really tired. I never used to be like that, but lately I just get super fatigued. It's weird. It just feels super heavy and my body feels super heavy and I'm just like, "Oh my gosh, I'm not going to eat anymore." So now I basically eat between I don't know, like 4 p.m. and 10 p.m. Like sometimes it's even like 5 p.m. and 10 p.m. So it's like a 5-hour window. That's all I eat. I try to get in like enough protein during that time. And so yeah, because of that, I've like lost a lot of weight. Yeah, people like a week ago they were like, "James, I can see it in your face. Like you just look like you're like unusually skinny." So yeah, I have though. I don't know why. Am I the only person that I'm 38? I suspect it has something to do with age. Because I never used to have it when I was younger. Even when I was like 35, this was never an issue at all. Just eat anytime, whenever I wanted, as much as I wanted. But now, if I eat anytime between, I'd say anytime before 4 p.m., odds are good I'm gonna get tired out from it. And yeah, so that's weird. De Beaumont resident says, James, will Kent Hovind be a guest soon? Nope. And then let's see. The fact that Marilyn, because I'm not okay, I'm not sure who this. You know what? The other thing too is Marilyn might be Human Girl. So Human Girl's been here for 6 years, and she also has like all sorts of like sock accounts that are like Human Girl, and then I can't remember. Oh yeah, she used to have like stupid energy whore, and so she's got all sorts of like weird sock accounts. I mean, if she is a she. And so Marilyn might be one of all stupid energy whores, sock accounts. We don't know that Marilyn is not. Let's see. This one coming in from Norex says Subway made a huge mistake hiring Jared Vogel instead of James back in the day. That's true. I really hoped that Subway would like call. Um, Iron Horse says, "What was the after show channel?" It's Matters Now. Iron Horse is Catherine MC says, "You're definitely getting enough sunshine, James?" Question mark. Yeah, I am. I'm in Vegas and I'm getting sunshine and it's amazing. It feels great. I love it here. Says you're definitely. And then I what was I gonna say? Let me try to remember this. I can't remember. What was I gonna say? There's something about this. Keep spooking your metabolism. I don't know what that means to spook it. And yeah, yeah. So basically, I'm doing intermittent fasting. Um, I was gonna say something. Was it about Subway? Oh yeah, yeah. I always hoped that they would like reach out for a commercial. Like, I would have been so happy. And now it could have been Dr. James, like Dr. Subway, and they still haven't reached out. I should I reach out? Is that weird if I reach out to Subway and I'm like, hey, I like technically I've got my doctorate, so would do like a little play in the commercial of like it's like, hey, it's Dr. Subway. Um, that seems kind of gay. I don't know. I don't think I'm gonna do it. Marilyn says I'm coming to Vegas in a couple of months. Well, I can tell you, I live in Summerlin. I can't tell you which street. Summerlin's a very big place because, like I said, I'm worried. Maryland is Michael. And yeah, Michael, like the tall blonde Marilyn is actually like the tall blonde Michael, and 6'4" Michael, and talks to himself a lot, weird stuff. Rev M's says Dr. Footlong. Thanks for your kind words. That sounds maybe I'll do that. But yeah, it is I wish Subway would just reach out. Instead they're doing like, you know, it's got to be Peyton Manning in their commercials. Couldn't be me. But good for them. I mean, having Peyton Manning, that's about as good as it gets in terms of like sports heroes that are alive today. I would say Peyton Manning is, you can't top him. In terms of MVPs, maybe the greatest ever. So, but yeah, thank you guys for your support. Love you guys. Looking forward to seeing you at the next debates. It's gonna be amazing. And then wait, hold on. Actually, I should say this. Couple things. If you want to come on and debate, we are looking for more people right now. So the email for Modern Day Debate, which is what I just checked, is moderndaydebate@gmail.com. So if you're a flat earther, we are finding lately that they're hard to find. So if you are wanting to come on and defend the flat earth, I'm at moderndaydebate@gmail.com. And so I check that email personally as I book debates, and we are looking for flat earthers, as seems like there are just not as many. But yeah, thanks for your support. Keep sifting out the reasonable from the unreasonable. We will see you at the next debate, which is going to be, wow, actually, that's such 2 days from now is the debate with Andrew Wilson and Apostate Prophet, which is about to pop up on screen. So yeah, 2 days from now, I will see you as I'll be there live in North Carolina, and very excited and honored to get to do the moderating for that debate in person. So come out if you're in North Carolina, come hang out with us, say hi, and I'll see you at the next one.